Okay, so good morning everyone and Assalamu alaikum. Welcome to the second day of the third World Conference on Byproducts of Palms and Their Applications by Palma. Thank you all for your participation. Today we actually have two amazing keynote presentations, and they will be followed by a discussion panel that is moderated by the National Industrial Development Center. Also, today we have only one morning session, and we will conclude after the lunch break. So it will be half a day only. Also, I just want to remind all our participants, and especially the poster authors, that we have like an amazing poster session that is outside the hall. So don't miss this opportunity to check out the posters and interact with the poster authors. So without any further ado, I would like to call Professor Muhammad Jaweed to start the session. Thank you.
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum and good morning to all of you. Thanks Midani for giving some brief introductions about to the program. So today we are going to start our session with the keynote speaker, and he is the keynote speaker third. He is going to talk about the date palm byproduct, a springboard for circular bioeconomy, which is very burning topic at this moment on how we can work on circular economy and all these things. So I just give the brief introduction about the Prof. Hamid Al-Mosli. He is a legendary professor and presently he is an emerite professor at the Faculty of Engineering and Shams University, Egypt. And he is basically the co-founder of and chairman of International Association for Palm Byproduct by Palma, who is organizing this conference with support of King Saud University. Prof. Hamid is recognized as a founding father of the date palm byproduct research and development, and one of the barriers of sustainable development of local communities. So he done a lot of works with the local communities, how to utilize the date palm waste and different products for the to make from the date palm byproducts. And he received numerous prestigious awards for his work, such as Khalifa International Award for Date Palm and Agriculture Innovation, 2013. And Professor Hamid has been working in project aiming at developing local communities and all villages of Egypt by applying developing project using their local resources since 1995. Project include production of blockboard, packet and arbesque from the palm midrib, production of non-traditional animal feed from agriculture residue, production of organic fertilizer from pruning product of date palms, dome palms and mango trees, and production of fig jam. And Al-Mosli contributed in the foundation of several research society and member in several strategic consulting and scientific committee. So without further delay, I call the Prof. Hamid to please come on the stage and give talk on the date palm byproducts.
Let me just adjust the microphone. Do you want me to put it on the...
حطه عندي أحسن. عيد تاني أحسن. عيد تاني أحسن. I'm highly indebted to Dr. Iman Atif Darwish for her invaluable contribution in shedding light on the technical heritage associated with the date palm byproducts in my presentation. Cultural and ecological significance of the date palm. The date palm has been assimilated as a cultural, spiritual theme in both the Jewish and Christian traditions. The date palm has been mentioned more than any other tree for 23 times in Quran. The date palm's huge benefits and wide spectrum of uses of its components has been highlighted in Prophet Muhammad's teachings by comparing the date palm with the Muslim. From the ecological point of view, the date palm represents a keystone species and the tree of life, creating in arid and semi-arid regions of the world a microclimate that offsets the effects of drought, preserves high soil moisture with low salinity, and thus creates a biodiversity hotspot that can shelter a wide range of plant and animal species in hot desert conditions, making possible the settling of human communities in these harsh conditions. What are the main date palm byproducts? Palm drips, palm leaflets, spadix stems, leaf sheaths, kernels, and waste dates. What is the status quo of date palm byproducts? In most cases, the date palm byproducts are treated as waste. They are either open field burns or left near to date palms and thus become a cause of fire in date palm gardens and a cause of infestation by palm red weevil, or sent to landfills. We need to propagate a vision of date palm byproducts as a renewable, sustainable treasure of renewable materials. The discovery of date palm byproducts applications in circular economy. Enzymes, food, beverage, pharmaceuticals, cosmetics, and natural wax, fibers, textiles, and composites. Timber and wood substitutes, cellulose and cellulose derivatives. Construction, isolation, and building materials. Organic fertilizers, compost, soil amendment, and coal. Natural fodder and silage. Wastewater treatment applications. Green fuels and bioenergy production. Furfural from date palm drips. Hemicellulose from date palm leaflets and rashes. Cellulose derivatives from date palm rashes as a sizing agent for cotton yarn. Cellulose fibers from date palm petioles. Well-bore strengthening using crushed date palm seeds and shredded waste car tires. Sand absorption by date palm leaflet sheaths, fibers panels. Now, what is our comparative advantage in the countries of the South, especially in the Arab world, in rediscovering date palm byproducts. It is the rich technical heritage of local communities in the South, in Arab countries, accumulated for thousands of years of use of date palm byproducts. Examples of traditional uses of date palm byproducts. Contemporary baking baths in Minya, Egypt. Ancient baking baths, Egyptian Museum, Cairo. Contemporary door made from date palm ribs, Fayoum, Egypt. Ancient Egyptian door made from date palm ribs, Middle Kingdom, Egypt, the Egyptian Museum. Contemporary chair made from date palm ribs, Egypt. Ancient Egyptian bed made from date palm ribs, New Kingdom, Egypt. Traditional fence made from date palm leaves with leaflets, New Valley, Egypt. Traditional boats, Shasha, made from date palm ribs, United Arab Emirates, Emirate. Chicken crate from date palm ribs, Egypt. Bread crate from date palm ribs, Egypt. Date palm ribs roofing in Santa Catherine, South Sinai, Egypt. My specialization is design of metal cutting machine tools, but in 1978 I saw the roofs of El Arish houses made from date palm ribs. This is my interest in the date palm byproducts. Palm date ribs movable huts in Dakhla Oasis, New Valley, Egypt. Date palm ribs corridor in Dakhla Oasis, New Valley, Egypt. Contemporary baskets made of leaflets coiled around spadix stem strands, Minya. Ancient discs made of leaflets coiled around spadix stem strands, Old Kingdom, Egypt. Now date palm leaflets. Contemporary baskets made of leaflets coiled around spadix stems strands in Minya, Egypt. Ancient baskets made of leaflets coiled around spadix stem strands, Middle Kingdom, Egypt. Date palm leaflets baskets, El Fayoum, Egypt. Ancient Egyptian basket from date palm leaflets, Middle Kingdom, Egypt. Contemporary slippers from coiled date palm leaflets. Ancient Egypt slippers made from woven date palm leaflets, Middle Kingdom, Egypt. Woven date palm leaflets hat, Fayoum, Egypt. Mats made from date palm leaflets, United Arab Emirates. Date palm spadix stems. Ancient sieve made from date palm spadix stems, Egypt. A traditional broom made from date palm spadix stems, Egypt. Ancient broom made from date palm spadix stem, Egypt. Mats made from date palm spadix stems, stands, Egypt. Ancient Egyptian mats made from date palm spadix stems, strands, Middle Kingdom, Egypt. Tray made from spadix stems, strips, New Valley, Egypt. Ancient Egyptian tray made from leaflets coiled around spadix stems, strands, Middle Kingdom, Egypt. Baskets made from spadix stems, strands, New Valley, Egypt. Home accessories and bags made from date palm spadix stems, strands, New Valley. A bird trap made from spadix stems and sheaths, New Valley. Ancient wig made from coiled date palm sheaths, Egypt. Date palm sheaths. Date palm sheaths rope, Egypt. Ancient Egyptian date palm sheaths ropes, New Kingdom, Egypt. Belts for palm climbers from date palm sheaths, Egypt. Ancient bag made from date palm sheaths, Old Kingdom. Traditional date palm sheaths, mats, Egypt. Ancient Egyptian date palm sheaths, mats, Old Kingdom, Egypt. Traditional donkey saddle made from date palm sheaths, Egypt. Ancient Egyptian bridle made from date palm sheaths, Old Kingdom, Egypt. Date palm trunks. Half trunks used as beams in traditional roofing in Arish, Egypt. Trunks used as beams and columns in traditional huts in Dubai, United Arab Emirates. Trunks used over streets in New Valley, Egypt. A door made from boards cut from trunks in the New Valley, Egypt. Furniture made from date palm trunks in Tunisia. Date palm petioles. Artistic sculptures made from date palm petioles, New Valley, Egypt. Date palm pits. A rosary made from date palm pits, Egypt. The last part of my presentation are interesting findings of date palm byproducts research. Sustainable biojet fuel production from date palm seed oil. There is no difference there is no significant differences in density across the trunk diameter and along the trunk length of the date palm. This is different from other palms. The increased utilization of date palm wood, midribs, spadix stems, petioles, and trunks assist to conserve the forests and supplement other wood species, which currently make up the bulk of local timber markets. Seed extracts has a great potential as an active film with antioxidant and antimicrobial properties, and thus can help maintain the quality and prolong the shelf life of food products. Preparation of activated carbons from dead palm petioles proved to be very effective. Temperature of activation 850 degrees centigrade during 30 minutes under CO2 is regarded as optimum. Long textile fibers, this is the work of Dr. El-Medani, from dead palm ribs and spadix stems, will have a brilliant future as a sustainable source of plant fibers. Bioactive components from dead fruit waste and seeds are potential nutraceutical and functional food ingredients. Antibacterial and antifungal properties of dead waste and also dates and dead seed extracts might offer an inexpensive way to protect the humans from different types of microbial infections. Untreated female leaflets have higher tensile strength and Young's modulus than male leaflets. Thank you.
Okay, Prof. Hamid, for opening our eyes, how can we utilize the dead palm, different byproducts for different type of applications. So now we open the floor for Q&A. So if you have any questions, please raise your name. First, who are you? Just introduce, and then you can ask the question. Thank you. Just give the mic to the person who is asking.
Assalamu alaikum. Muhammad Midani from the German University in Cairo. Thank you, Professor Hamid, for this very insightful presentation. I think it was really amazing to see the linkage between the traditional crafts that still exist in some villages in Egypt, in Saudi Arabia, and the Emirates, and those of the ancient crafts that have been already present in the past. But what about the future? I guess you mentioned so many modern applications, whether in pharmaceuticals, in textiles, and other. But also yesterday we've seen Professor Fruwald talking about the oil palm trunk utilization. So I guess in different parts of the world they are taking leaps in the utilization of other byproducts of different palm species. But when it comes to our own here in this region, date palm byproducts, we see that it's still limited to those traditional crafts, and we don't see any significant industrialization. What do you think is the main reason for this?
What's the more question?
Okay, I'm saying here in the region, we don't see any industrial model for utilization of the date palms byproducts in future applications or modern applications? They are still limited to traditional usage and applications.
I think that our region were subject to Western influence. And this Western influence was against our traditions. We used to imitate the Western style of life, and this has led to the neglect of so rich heritage related to the date palm byproducts. So I think we need to revive the interest in these byproducts. We need to have more confidence in ourselves and in our materials. This is a cultural issue.
Yes, Assalamu alaikum. Good morning. Arno Frühwald from University of Hamburg. I follow completely what Prof. Musli said. So it's an influence of long history and tradition, how to use the palm byproducts. This is the major reason to my understanding. I've seen very many applications of other palms as well. And you can compare date palm with its tradition with coconut. Coconut has the same problem of industrialization because it's for hundreds and thousands of years has been used, and still people remain in the same utilization strategies because they have learned it from a long time. And another influencing factor is the regional distribution. You know this better than I know. The date palm are quite distributed, not very dense plantations on large areas. So the quantities regionally available are rather small. And this limits the industrial approach of using this byproduct, this source of byproduct. Same as with the coconut palm. We did have many big problems in supplying enough wood or other fiber material for industrial application. So even a sawmill of 5,000 cubic meter per year was almost not existing because of the supply, long-distance supply, rural areas. It's totally different with the oil palm. The oil palm has, I regret to say, no tradition in utilization, the byproducts. And it is all planted on huge areas, closed areas. You have 10,000 hectares, you have 100,000 hectares, you have hundreds, thousands of cubic meters of trunks and hundreds, thousands of tons of fiber material in a distance of 20 kilometers. So this is a material for industrial purposes. And you have a new thinking because nothing was there before. So this is a totally new approach. And it's an industrial approach as large plantations area is, same as with the palm oil production. This is industry, really big industry. And we will see the really big fiber utilization industry with oil palm as well in a couple of years, definitely. But still, with the other palms, I like this tradition, but it's difficult to industrialize. Thank you.
Yeah, thank you, Prof. Arno. There is one or two questions back. Because earlier there, so just we take one and then we have one.
Thank you.
The mic is there. Just mic pass to him.
Yeah, my name is Mohammad Rajaul Karim. I'm working in Center of Excellence in King Saud University. Thank you very much, Rob, for your nice presentation.
Hello.
I have one question. I saw you mentioned that the byproducts from the palm trees, it can be converted as a activated carbon in 850 degrees centigrade for 30 minutes with carbon dioxide. Is it carbon dioxide or other inert atmosphere? Just I need to know actually what is the procedure for the optimum temperature of activated carbon?
So through the pyrolysis or how?
Pyrolysis.
Through pyrolysis.
Right.
So you have any idea about that? He's asking to convert that into the activated carbons, dead palm waste.
CO2 is used.
Yeah.
As
I will answer this. I will answer this. For calcination, you need, I think, from 350 to 800 degrees centigrade.
Yeah.
You can use inert nitrogen or CO2 or mix of them also.
Mix of them. Okay. Thank you so much. You asked
I am commenting on the Prof question. The using of the palm byproducts. The main problem is the cost, and the other product made from petrochemicals are much cheaper than these products. So the problem, I think, the government or the local authority need to support these type of activities and production from palm trees. Otherwise, they cannot survive. The economical struggle in the market. The cost of producing any of these products, I think, is 5 times the cost of production from petrochemical products like baskets, mattresses, or doors, or whatever it is. So by itself, this industry cannot survive from economical point of view, but it can survive by support of local authorities, cultural authorities, or government to protect this as you mentioned, from cultural point of view. Only some products which has economical value has succeeded, like production of oil or fructose or activated carbon. Some of the products which they have commercial and specific values, I think, have already been succeeded. But most of the products which I have seen, I think, at the moment, they cannot compete with the industry, the new industries from petrochemicals and other products.
Okay, thank you so much. That we have a limited time, so because we are already late on the, I can just take one last question from there. He's raising the hand from long time. So we have the last question.
Thank you very much. My name is Hassan Dinar from King Faisal University, the Date Palm Center of Excellence. In contrast, actually the date palm biomass, there is a lot of innovative products which are marketable. It's not that we are continuing in the traditional methods. Now in the center we have almost about 36 innovative products ranging from pharmaceutical and medical products up to food and other transformation.
I visited your center 4 years back with the Prof. Osman,
Okay, thank you.
It's very nice that you are doing good work. Okay, so now we are, Prof. Hamid, just you respond.
I have just a comment on the date palm byproducts are very cheap. It is not economic to transport them to different places. So I advise to make the products as near as possible to the place of location of these byproducts.
This is not problem from the date palm. In Malaysia, we have the wild palm biomass. But the problem that transportation cost is very high. Like 50 ringgit things, you need to pay 150 ringgit for transportation. So that is the big issue, and I agree with him that we are talking about sustainable materials and all these things. But the main thing is the costing of that product, Because I work a very big project with the international partner in the UK. We develop a biocompostable packaging materials, But without the support of the governments and making a legislation, it's very difficult. In Europe, it's implemented because they are making the legislations to utilize the sustainable materials. Thank you. Prof. Hamid, let's finish the things.
Okay.
Okay, just.
There is a strong relation between the past and the present. We worked in many governorates. We worked with the youth on using palm drips, but the girls used the leaflets much more successfully because they relied on the traditions of their grandmothers who transferred to them the skill and the familiarity with the material.
Okay, Prof. Hamid, thank you so much. So now I call the Prof. Usman on the stage to please come on the stage and give the memento to the Prof. Hamid. Okay, without further delay, we are going to move forward with our second keynote speaker. He is one of my good friends, and we are looking to meet each other from long time. So, Alhamdulillah, we meet after 9 or 10 years through this platform. So, Prof. Abu Al-Qasim Kass is currently working as a director of the Nano-Composite Center at Moroccan Foundation for Advanced Science, Innovations and Research, Institute of Nanomaterial and Nanotechnology in Rabat, Morocco. His research area include the hybrid reinforced, filled polymer composite, advanced material, graphene nanoclay, lignocellulosic reinforced polymer composite and modifications and treatment of the lignocellulosic fibers. And also is working on the polymer blends, and he have a good teams because I continuously watch him. He is working lot of works on the dome fibers, one another form of the palm. So he have lot of works, and also he works some on the date palm fibers. And we also together edited some book together through the Springer on the topic of nanoclay and all these things. So without further delay, I call the Prof. Kass to please come and give the talk on recent advance on the biothermoplastic based date palm fibers. Please come on the stage.
Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Thank you very much for organizing committee to invite me for this prestigious conference and to give me the opportunity to meet my brother, Professor Jawid. We work and we collaborate more than 10 years, and it's the first time we meet. Thank you very much for the new technology that give us this opportunity. Sincerely, after the conference of Professor Morsley, I have the question as a researcher, and we are the duty to ask, how can we update and increase the quality of the several applications in our history to use that palm fiber? I think that's the approach. We must ask this question. How can we improve the quality and improve the industrialization of some product that is made manually? We focus now of the new approach, the use of chemical approach to extract some the high value of products from natural fibers in general, as especially on the date palm fiber. I will talk about the recent advances of the recent thing of the manner to have our research in the natural fibers or the work on that fiber in the market as high value. Please. Thank you. In my laboratory, I have several work on natural fiber and that palm fiber to extract, for example, the cellulose microfibril, cellulose nanocrystals, and cellulose monoliths. These, especially these, can have several applications in some treatments because it offers a lot of surface, for example, for wastewater treatment to extract some specific waste products, waste components in the water, and also the cellulose hydrogel. And as application, the manufacture of film as 100% of cellulose. That is, at laboratory scale, we can use from a solution as viscose product to produce a film, but it need, at NUDAI, it is used at laboratory scale by evaporation of solvents. In this case, we use the water to obtain a transparent film. It's like a plastic film, the same transparency. But the production at industrial scale is under study. And for this, our dream as a researcher and the dream of our researcher is the industrialization of this approach. In our main, we have the extruder. In this extruder, we have three parts: the feeding of the materials, the transformation states of the materials. Here in the extruder, we use a thermal effect of temperature to change the state of the material. And we have the cannon drain or the compounding to obtain the composites or the granular composites between matrix and reinforcements. That is our dream. One day, we use in the feeding the cellulose and we obtain a film to industrially, for the application as the industrials. Here we have the definition. To have these or to apply these, the material must have a thermoplastic behavior. What is the thermoplastic behavior? Is we have the materials and under temperature, we change the state. That is usual. We talk about, for example, PP or polypropylene or polyethylene. And we have several properties that is similar to what we obtained when we produce the film from cellulose. We have the transparency, we have the acceptable mechanical properties, and we have the barrier, the barrier properties, especially when we use it in the packaging. To reach these, I will talk about two approaches. The molten approach, as we see, we have, for example, for thermoplastic or for semi-crystalline polymer, we have the thermal properties. These thermal properties when we have the displacement between the chain. Under temperature, it facilitates these. And we have the degradation, the onset degradation of the materials, and the process into temperature is chosen between the two temperatures. And we chose the temperature higher than thermal molten temperature to reduce the viscosity. That's the approach when we use the standard thermoplastic. In the case of the cellulose, we have the same shape. We have the linear chain, and we have the intermolecular hydrogen bond. It's the weak bond. And under temperature, the problem, under temperature, we have the degradation of the bond inside the linear chain before the displacement intermolecular. We can ask these. The intermolecular chain is weak than the bond inside the linear. But we have the 3D cross-linked of the chain. It's the difficult. We have the density of the hydrogen bond is very higher than the density of the bond inside the chain. It's for that we have the degradation. The onset degradation is before the displacement of the chain, of the linear chain. In this, we cannot use the molten approach because the material is degraded. In this, in several work, we try to use the natural fiber as reinforcement in thermoplastic composites using the standard industrial techniques like extrusion or injection molding, and we can reach more than 20% of natural fibers to produce a composite by extrusion. But the problem, we still say the change of the color, and we don't talk enough of that. That is mean we have the degradation of the natural fibers. We can improve the adhesion at the interface, but different techniques, but different functionalization, but the development of a new molecule to bridge between the matrix and the reinforcement, but we still have the degradation and the change of the color of the material. And the color is decay in the industry because we must have the neutrality of the color to add a master batch of the color and to produce the part of a specific color. In the case of use of natural fiber, we still have the brown color. It seems that we have the degradation of the materials. And the second approach is the cross-linking. The cross-linking, when we produce the bead from hydrogen, we have the cross-linking media, and we have the bead before cross-linking. The size is depend on the tension of the surface and the configuration of the system. And we can obtain the cross-linked bead, which can be used also for different treatments because we have the ultra-porous materials. This is the same used, for example, here for the ketosane and the black carbon for specific uses, and obtained the bead, and this bead can be used to for absorption for specific components. For example, we use it for extraction of the cadmium from phosphate. As you know, Morocco is the first exporter for the phosphate, and the Moroccan phosphate, we have more than 60 ppm in cadmium, and we must extract it. Here we have a process which is used in textile to obtain the rayon from cellulose. And we have the same batch for the treatment of the cross-linking of the material. We will use the same approach with the feeding with the viscose solution. And we ask how can we produce the viscose solution from our products or from the natural fibers. Different steps of treatment we will follow. Our raw materials in these This is our objective, to obtain the viscous materials which can be feed the process to obtain a cross-linked in continuous production for the cellulose. Our raw materials in this case is the pulp of cellulose. It is used, for example, it is presented yesterday to produce the paper. This is the microfiber with specific length, and we use this for the first step is called steeping. We saturate the material with sodium hydroxide, and before obtained the pulp of paper, we use the sodium hydroxide to extract the lignin. And now we use it to saturate the material and to obtain the as gel configuration or structure of materials as viscous materials. It's called soda cellulose. After that, we use carbon disulfide to open the link and to have a more functional group to be treated and to cross-link it during when we have the contact in the cross-linking media. And we obtain soda cellulose or sodium cellulose xanthate. And the last step is the mixing. We have we use a small quantity of sodium hydroxide to have a more homogeneity of the solution and to have what we called a solution with the stable state. And we cannot have a decontamination of the materials, and we obtained the viscous materials. These viscous materials, which we must have a specific properties, especially rheological properties, because we will use it in the extruder or a process similar to extruder, like what we use, for example, of polymer. When we use and we talk about the grade of polymer, is for extruder or extrusion or for injection molding. These depend on the length of the molecule, and we do some characterization. Rheological, for example, plate at melting state, or we use the MFA, melt flow index. It gives us properties how the materials must flow under a specific day. For rheological, for us, we have different kind of rheological behavior, but the main character that our viscose must respond is thixotropic nature. This thixotropic nature, it means that the material have different viscosity depending on the shear rate. And at high shear rate, we have a low viscosity, and at shear rate, small shear rate, we have a high viscosity. These allow us to have a draw, right, or the flow of the materials with the high viscosity, and we have enough time to treat the material inside the cross-linking solution. That is the horizontal extruder. But in our case, it is difficult to use this process, and we can use a vertical flow of the materials. This is a schematic of how can the process will be designed out and can be worked. This continuous process, we have the quantity of the materials and the pushes throughout a day. This inflates day to have a film, and we have a regenerating media of cellulose. And also, we can use a system as extruder. And we have the screw and the material flow today, and we can have a continuous flow of the material and continuous process. Now I will talk about the generating media in this process. Here in our laboratory, we work on the transformation of this injection molding machine, which is vertical, and it is with a low pressure, because here we have a screw as extruder to transport the materials throughout the day. And for regenerating batch or regenerating media, we have a specific time of the treatment. Is for that the material have this patch, and after that we have the material. We need just washing and drying the material to obtain a film of cellulose. And this, we use sulfuric acid. We have sodium cellulose xanthate in the in, and the out we have materials, our cellulose, and after washing we have just a film of cellulose. And I will talk about the main point is the viscosity and the rheological behavior of the material. This is the process which is used actually to produce a thin rayon of from cellulose. Exactly, we have the same approach to obtain the viscous solution. And the difference, and in the case of the rayon, we have more specific surface of the treatment, and the time of the treatment is very short. In the case of the film, we must have a thin film, and the duration of the treatment is very large. And other use of the viscous materials, as I say, is the extrusion, and we can, for the coating, use the spin coater to deposit a surface of coating of some functional application in the surface, and or the use of the fiber, and after that we can use the fabrics to produce some specific part. And this approach is very used in the textile industry. And our challenge is to control the properties of the film. We can produce the film, but for application, we must respond to the specific properties. Here, I will talk about the ductility of the materials. It's the capability of the material to deform plastically before fire. And we need this for application. When we talk about a film of cellulose, the first application is the packaging. And the packaging, we need some plastic deformation or thermoforming of the materials. And to control the rigidity, I will talk about this. And also for the process, we must have a specific rheological properties, especially the control of thixotropic of the materials. And for the rigidity, we can talk about the nanocomposites and use different nanoparticles to reinforce the matrix. And for this, we have in our laboratory, We work on the synthesis of different nanoparticles, cellulose nano crystals, graphene nanosheets for graphene and different shapes to obtain graphene and its derivatives, carbon nanotube, carbon nanofibers, metal oxide. These we need it for specific application. For example, when we want to talk about the electrical conductivity of the film, we need to introduce some specific particle like metal oxide nanoparticles, which can be used at the small quantity, and we can respond to the specific application. Also, the use of clay nanoparticles, and in Morocco, it's rich on the Bantonite on the north of the Morocco. It's for that our first project is to valorize in my team to valorize the Morocco research. We worked on the different kind of nanoparticles and the Bantonite from the north of the Morocco to produce the nanoparticles. And here, we can produce the materials, and we as a researcher, and we must respond to the specific application. Can we predict the behavior of the material before formulation? But it is sure when I mix two components, I will obtain the third one. But can I predict the behavior of the result of the mixture of products? And for that, it is very important to work on the modeling of the materials and to use the theoretical background, because we work on the applied researcher, and we have the boundary for the fundamentals and the applied, and we must use some fundamentals to produce materials with specific properties to control, for example, mechanical, thermal properties, rheological, and study, for example, in the process when we talk about the fiber, the orientation of the fiber along processing of the materials. And when we talk about the modeling, especially in the mechanics, we base our modeling on mechanics of materials, which is based on two assumptions: the continuity of the matter and the continuity of the transformation. It means that when I take a volume at micro scale of the material, it is sure that inside this volume we have the material. All components that describe the materials. And when we talk about the continuity of the transformation, this is continuity of the materials, and this continuity of the transformations, it means that if we have 2 points, closed 2 points, after transformation or after deformation, we still have the 2 points closed, and they deform. In this, I can talk of the matrix that describe the transformation of the materials. Donc, we need on the continuum of mechanics to have or to validate the two assumptions. That is a different formula. And here, in our case, in the modeling, we can model at micro scale, and when we switch to macro scale, we use some formalism, and the properties of particles is different of the micro scale of the materials is composed by different particles. And the question: can we use this approach or homogenization approach based on continuum of mechanics to model the materials at nanoscale? as I say, at nanoscale, we must to model from nanoscale to microscale. I will take the elementary representative volume. And at nanoscale, when I take this volume at the nanoscale, probably inside there is no materials. And the first assumption, the continuity of the materials, is not validated. And the transformation, we talk about the transformation in continuous mechanic and infinitesimal displacement. This is at the nanoscale. And the case of nanocomposites or nanoparticles, we can have this deformation at nanoscale in the scale of the infinitesimal, and the second assumption is not validated. And we can see that all formalism from continuous mechanics cannot be used. And in this, we need the collaboration on physicians and chemists, because we need the modeling and the describe of the materials at atomic scale, at the nanoscale, and we must model the link. It's for that, for example, when we talk about the composites of the materials, we talk about the reinforcement and the matrix, and we cannot take the interface as the third phase and take it as phase in our model. And for the modeling, we can follow some point. For example, aspect ratio that we talk about the nano particles, it's very difficult. And we must model these or use the high, for example, atomic force microscopy or the TEM to obtain the characterization of the material to input and to determine the aspect ratio. Fiber aspect ratio, when we talk about aspect ratio, it's the shape, and here we talk about the shape and the length and the diameter of the fiber. And we take the interface. The advantages when we take, for example, the viscose reinforced with the cellulose nanocrystal, we didn't have the problem of the compatibility. We have the same functional group in the matrix and in the reinforcement. And we must talk about the good dispersion and distribution. Both we have the adhesion at the interface, that's the first parameter, and the second parameter is the design of the processing of the equipment, how can be dispersed and distributed the nanoparticle inside the matrix. In the future, it's sure that at the engineering scale, we must design the process responding to different states, and we must work on how can we use the film as in terms of forming. We cannot use the temperature, what is the equivalent, and can we give us the same result, and how can we use, and can we recycle these materials, and can we see the result? The cellulose can be our, like a pulp of the paper, and introduce it. It's sure it's not the same, but can be as the first step to recycle the materials. Thank you very much.
Thank you, Prof. Kass, for taking totally technical side, for more research on that one, fundamental research, and towards how it can be fabricate different types of product and characterizations and all these things. So now we open the floor for the Q&A. So please, if anybody have questions, please. His student want to ask the questions, okay, with supervisor, okay?
Actually, Professor Kais, I am his grandson because he taught his son, and then I'm his grandson.
Okay, so you are his student and then
Yeah.
grandson, okay?
Yeah. So I just want to challenge my grandfather for a simple question, because if we look carefully, us like in the Morocco region, I mean the whole MENA region, Middle East and North Africa, we have tight competition if we compare ourselves with Europe, because they have forests there. So they have unlimited supply. So to balance this with date palm or let's say doom, how can we balance or how can we compete with them when we don't have enough supply?
Thank you very much, Brother Salim. Is the student here to my students. I am agree with you. The competitive in we use, for example, in Morocco, we talk about the alpha fiber, dome fiber, date palm fiber, but the concurrence and it cannot assume. But it's for that we talk about the high value of the materials. We can talk, for example, to produce the paper. We didn't have more wood to the balance between wood and the fiber, but for the high value product and to extract the high value component from the natural fibers, I think that it's based on the knowledge. As in these, we can have the balance.
Thank you, Prof. Kass. Thank you so much. Any other questions? The Prof. Home want to ask question.
Hello, Professor Kass. Thank you so much. I'm Home Dakar, University of Portsmouth, UK. You really captured theoretical aspect, experimental aspect, as well as modeling aspect in your presentation from nano to macro. Have you received any results from your experimentation, and can they be related to particular applications?
Thank you very much for your question. Yeah, we have some results, but it's still at the laboratory scale. And we work on the unit operation to validate unit operation in the process. But we have some results, and it is competitive, and we can have the application. And also, we characterize our materials to respond to the specific application, especially for the packaging. How can we enlarge the life of, for example, the feed inside our functional packaging?
Right. Yeah, just to elaborating on that, we are also working on packaging material using date palm fibers, using dry blending and melt blending and comparing their properties. And some of that result I'll be sharing later in the presentation. I think achieving the challenge, the permeability, water vapor permeability, oxygen permeability is a big challenge. I'm sure you are facing that as well.
Thank you very much. Yeah, when we use, for example, I talked about the Moroccan clay, the bentonite, which can be transformed on the monomer unit at the nano scale. It is useful for to improve the barrier properties of the materials, and we work on this. It is very difficult to disperse and distribute the nanoparticles inside the matrix, but it can be used for this. Thank you.
Okay, please give the mic to him. Okay. We have time. Don't worry that we have time, so we will take more questions.
Thank you, Prof. I'm just commenting on your grandson question. It is not a matter of competition between West or east. This is your work is about scientific discovery and scientific research. So it is growth to the international community. The method and discoveries presented in your work, and the scarce of the material or the limited of the raw material, it is not the issue here, because I'm thinking you are working in a approach of research and scientific work that to use the local material and develop it into biothermoplastic, which is a useful material. And the value in this the value of the product is what is meant here. Is not rather than the volume of the raw material available or not. Thank you.
Just give the backside. There's a lady. She's want to ask question.
Thank you very much. Professor Zahia Kabouche from Algeria. Congratulations for your nice presentation. Really, it was very rich. I would like to know if you have, for example, paper which is not so thick, and you want to improve its thickness. For example, in chemistry, you have to use chromatographic paper, like Wattman paper, number 3, or just for filtration, for example, number 1. What are the ingredients that you have to add to improve the quality of the paper, especially in the thickness?
In the,
yeah.
When we talk about the paper, we have first the grammage of the materials. For example, this paper, we have 80 gram by square meter. But in these, we can work on the thickness. At the laboratory scale, paper making, we have the void. We must increase the void to have more compact materials.
That's right.
Yeah. That this in the process, and for the formulation, for example, we can use the calcium carbonate, which is usually used in the formulation of the materials, and can enlarge the thickness.
Okay. Thank you.
You are welcome.
Okay, there's just pass the mic to him. That just next to you.
Dr. Salah Al-Eid from King Faisal University. Thank you very much for the deeply scientific presentation. The value-added products is really fascinating. I have 2 points. The first one is, what is the behavior of the products, the thermodynamic and rheological behavior when we recycle such films or beads? Are they going to follow the same melting points, glass transition points, and so on? This is the first question, because those properties are very important if the products will not collapse or need further costly treatments. This is the first point. The second point is, how long such products to be I think it's biodegradable. What's the length of the time also? And you added silver to the treatments and NaOH. What's the environmental impacts? How much you add, I don't know actually, but this is also a point of concern. And the third one is the economical feasibility of such a process. Thank you very much.
Okay, a lot of questions.
Yeah. Thank you very much. For the first question, it's sure. After recycling, we have the viscosity decrease. That is sure, because with the different, we start by the mechanical grinding of the material to be recycled before the solution of the materials. That's the rheological behavior must be controlled, and we must be added some component to increase the rheological behavior of the materials. The second question.
The second question is about how long the time for them to be biodegradable.
Sincerely, we didn't conduct this study, but this the natural, 100% natural product in the nature. When I talk about the added for some synthesized particle, this corresponds to the specific properties. But when we talk about the packaging, we must be careful. We use the viscose reinforced with cellulose nanocrystals.
And just I want to add him that on the biodegradability, there is a different test as per the country, you know. So like, for example, if you go in Europe, EN 13432 or something like that, so that one within the 6 months, the product can be decomposed in the soil, and the soil quality did not spoil with your materials, you know, like that. Germany have another, so different countries have another. So if you want to do, you have to follow up lot, you know, means that one. So it's a very big area of discussion and the research on that one. So I think with the limited time,
just for the, when we talk about the film or biofilm for the packaging, it is not, it cannot be used as the, what we see as plastic. It's the specific application. Now we talk about the bio feed. That is, the packaging also must be bio. It's for that we use for the challenge. We cannot compare between thermoplastic film and film from cellulose, for example, for cellulose.
Okay, the Prof. Kass, thank you. So we have big applause for the Prof. Kass, and just Kass the bit. And now I want to call the Prof. Ali Hassan Al-Marzuki from United Arab Emirates University to come on the stage to give the token of appreciation to Prof. Kass. Okay, Prof. Ali Hassan, thank you for that one, and thank you, Prof. Kass, for giving a good. So now we are moving forward to the next stage of our panel discussions. In that, we are going to discuss on the industrial partners, that how it can be, what we are discussing, how we can implement it into the different product and commercial applications of this. So the topic of our panel discussion is role of government agency, that is very important in integrating and empowering the industrial sector of palms, dates, and their derivative products, you know. So now I'm going to hand over these sessions to the moderator. So before I will hand over to the moderator, Dr. Abdullah Khalifa M. Al-Mubarak. I just want to give some brief introductions about him. Presently, he is a director of the food processing sector of National Industrial Development Center, Saudi Arabia. And he have a bachelor degree from King Saud University in Community, Health and Nutrition. He hold a master degree from the California State University in Nutrition and Food Science. And he have also the PhD degree from King Saud University in the Nutrition Science. He has a practical experience in the government and private sector for more than 15 years in the field of policies and regulations in the food industries. Currently, he is the director, as I mentioned earlier, he is the director in the food processing sector at the National Industrial Development Center, affiliated with the Ministry of Industrial and Mineral Resources. So now I call the Dr. Abdullah Khalifa, please come on the stage and take the moderator job. And I also call the panelists, please come on the stage. Musalla Fayyaz Al-Zubaydi, Khalid Fahad Al-Khalid, Hassan Saleh, and last one is the Nasir Al-Bishi. Please come on the stage, Haftek. So now the stage is free.
Thank you so much for introducing me, and I'm so happy to be here. As per the direction from the committee, the panel session will be in Arabic, so you can use the device for the translation.
phone, we can give the translation.
Sure. Also, there is a phone for translation as an assistant for you. If you need it, you can use it. بسم الله الرحمن الرحيم. اللهم صل على محمد. نبدأ الآن الجلسة الحوارية الثانية بعنوان دور الجهات الحكومية التكاملي والممكن للصناعات في قطاع التمور والنخيل والصناعات التحويلية. أرحب بالجميع ويشرفني أن أكون متواجد اليوم كممثل للمركز الوطني للتنمية الصناعية في هذا المؤتمر القيم والمهم بمواضيعه وجلساته الحوارية، كما يشرفني أن أكون المحاور لهذه الجلسة. مما لا شك فيه أن قطاع النخيل والتمور والصناعات التحويلية يلعب دورا حيويا وفي الاقتصادات المحلية والدولية، ويسهم في تعزيز التنمية المستدامة وتوفير سلع ومنتجات ذات قيمة عالية. ومع ذلك فإن الصناعات تواجه تحديات تتطلب تدخلا حكوميا فعال لتحقيق نمو مستدام وتعزيز للتحول الصناعي. خلال هذه الجلسة سنسلط الضوء بإذن الله على عدة محاور، وهذه المحاور سوف تعكس الأدوار من الجهات الحكومية المشاركة معنا في هذا اليوم. لذا يسعدني أن أعرف بالمشاركين في الجلسة. يسعدني أن نرحب بسعادة المهندس مصلح بن فايز الزبيدي، مدير عام قطاع الصناعات الغذائية بوزارة الصناعة والثروة المعدنية. كما أرحب بسعادة الأستاذ خالد بن فهد الخالد، رئيس قطاع المياه والمرافق بهيئة المحتوى المحلي والمشتريات الحكومية. كما أرحب بسعادة الأستاذ حسن بن صالح أبا الخيل، مدير إدارة تفتيش مصانع الأغذية بالهيئة العامة للغذاء والدواء. كما يسعدني أن أرحب بسعادة المهندس ناصر بن صالح البيشي، مدير إدارة الجودة بالمركز الوطني للنخيل والتمور. صباحكم بالخير. لا تسمحون لي أن أبدأ مع سعادة المهندس مصلح. أطلق صاحب السمو الملكي الأمير محمد بن سلمان بن عبد العزيز آل سعود ولي العهد ورئيس مجلس الوزراء رئيس مجلس الاقتصاد والتنمية حفظه الله الاستراتيجية الوطنية للصناعة في أكتوبر 2022، الهادف لوصول اقتصاد صناعي جذاب للاستثمار يسهم في تحقيق التنوع الاقتصادي وتنمية الناتج المحلي. ودي توضح لنا مهندس مصلح عن نبذة مختصرة عن الاستراتيجية الوطنية للصناعة ودور وزارة الصناعة في هذا الجانب.
صباح الخير على الجميع. لما ندخل الاستراتيجية الوطنية للصناعة ونعرف فيها، بناخذ رقمين كذا سريعة في الاستراتيجية تورينا ايش الضخامة اللي في الاستراتيجية الوطنية للصناعة. الاستراتيجية الوطنية للصناعة تهدف انه الناتج المحلي للصناعة يقفز من 331 مليار في الوضع الحالي إلى 895 مليار في عام 2030، يعني قفزة ب3 أضعاف. قيمة الصادرات تصل إلى 557 في عام 2030 مقارنة ب169، يعني حوالي 4 أضعاف. أيضا عند بناء الاستراتيجية بنيت على مستهدفات الرؤية، وهذا الشيء اللي يعني خلق التكامل ما بين الجهات، إنه في إطار عام اللي هي رؤية المملكة، كل الجهات تسعى وفق هذا الإطار في تحقيق المستهدفات. فكانت متوائمة مع منهجية الرؤية من حيث تعزيز الناتج المحلي وتعزيز الصادرات، إضافة إلى توفير فرص العمل وتعزيز التحول والتنوع الاقتصادي. من حيث الجاذبية للمستثمر، بنيت على تنافسية المملكة والقدرات الموجودة للمملكة، وهذا يعطينا أنها استراتيجية ليست طموحة فقط، ولكن طموحة واستراتيجية واقعية. من حيث أولويات التنفيذ، راعت جاذبية السوق وراعت ماذا ستحقق المملكة من مكاسب، وبناء عليها درست القطاعات حوالي 65 قطاع، نتج عنها التركيز في 12 قطاع. أولى يعني من القطاعات التي حظيت بأولوية هي قطاع صناعة الأغذية. أيضا ركزت على 118 سلعة، من هذه ال 118 سلعة اللي هي سلعة التمور. فاليوم هذه هذا المدخل لنا في سلعة التمور. لو طبقنا جميع ما ذكرته سابقا من حيث الجاذبية ومن حيث التوفر ومن حيث أولوية التنفيذ، نجد أن قطاع التمور يحظى في المملكة العربية السعودية بأكثر من 36 مليون نخلة، أكثر من 1,700,000 طن إنتاج. يعني قطاع واعد للاستثمار فيه، قطاع واعد لأن يكون من القطاعات ذات الأولوية في الاستراتيجية الوطنية للصناعة. وهذا التكامل إن شاء الله اللي موجود، سواء التكامل العلمي أو الحكومي أو من الجانب المستثمرين، بإذن الله أن نرى القطاع هذا في المكانة التي يستحقها.
يعطيك العافية. فعلا بما انتهيت ممكن ننتقل إلى مهندس ناصر. زي ما تفضل المهندس مصلح أن الحكومة الرشيدة حفظها الله يعني أولت اهتمامات كبيرة في مجال قطاع النخيل والتمور، وبناء على ذلك أنشئ المركز الوطني للنخيل والتمور في عام 1432، والذي يهدف إلى تطوير واستدامة قطاع النخيل، والهدف منه أن يضع المملكة العربية السعودية هي الرقم الأول في هذا المجال. ودي تعطينا تصور عن أدوار المركز والمبادرات اللي تقوم فيه حاليا. تفضل.
تمام، صبحكم الله بالخير جميعا. مثل ما تفضلت، المركز الوطني للنخيل والتمور انشأ بأمر سامي لتنمية تطوير قطاع النخيل والتمور. يهدف إلى عدة أهداف، اللي هي منها رفع صادرات المملكة من التمور، تشجيع الصناعة الحديثة من التمور، كذلك رفع جودة قطاع النخيل والتمور. من مبادرات الصناعة أو من مبادرات تشجيع المركز للفرص الاستثمارية أو الصناعات الحديثة من التمور، المركز يعمل حاليا على عرض الفرص الاستثمارية من المنتجات التحويلية ومن مشتقات النخيل، بحيث عملنا على أكثر من 14 فرصة للمستثمرين لتبنيها أو توسع الأنشطة الصناعية القائمة. كما يعمل المركز في هذا الصدد أيضا في الربط ما بين المنتجين وكذلك المستثمرين في توفير المواد الخام التي تدخل في المنتجات النهائية من المواد الخام، سواء مخلفات النخيل أو من التمور، في الصناعات اللي تشتق منها، سواء في صناعات تحويلية من التمور أو صناعات الألواح الخشبية والMDF من الخشب.
ممتاز جدا، يعطيك العافية. الانتقال للمحور الثاني اللي هو سن التشريعات والسياسات الحكومية وتعزيز المحتوى المحلي. أبدأ معك أستاذ حسن من الهيئة العامة للغذاء والدواء. لوحظ في السنوات الماضية إنشاء العديد من السياسات والتشريعات وتحديث كذلك في السياسات والتشريعات في القطاع الصناعي بشكل عام وفي قطاع النخيل والتمور. إذا بإمكان أن تعطينا تصور عن دور هذه السياسات في التنمية وكذلك جهود الهيئة العامة للغذاء والدواء في هذا الدور والدور الرقابي في نفس الوقت. تفضل.
في البداية شكرا أخوي عبد الله. في البداية شكرا أخوي عبد الله على هذا الطرح، وصبحكم الله بالخير جميعا. نحن في الهيئة العامة للغذاء والدواء دائما نحرص على وضع اللوائح والاشتراطات لضمان سلام ومأمونية المنتجات الغذائية المصنعة داخل المملكة العربية السعودية. واحدة من أهم الأهداف السنوية عندنا في الهيئة العامة للغذاء والدواء هو تمكين المستثمر وتمكين الصناعة المحلية من خلال توضيح الاشتراطات ذات العلاقة وتوضيح اللوائح بما يتوائم مع الاشتراطات المحلية وكذلك الاشتراطات الدولية لتصدير المنتجات الغذائية إلى دول العالم. طبعا في الهيئة خلال السنوات الماضية أنشأنا فريق مخصص لدعم المصانع في تحقيق متطلبات واشتراطات بعض الدول المصدرة لها المنتجات مثل منتجات التمور. أنشأنا فريق بما يسمى بفريق داعم. هدف هذا الفريق هو زيارة كل مصنع من مصانع الغذائية في المملكة العربية السعودية، تقديم الدعم اللازم من ناحية أنواع الاشتراطات التي يتطلب توفيرها أو تحقيقها لضمان سلامة ومأمونية المنتجات الغذائية.
جميل جدا، جهود تشكرون عليها وملحوظة في مجال الصناعة. أستاذ خالد، يلعب مفهوم المحتوى المحلي دور كبير في اقتصاد البلد. وكذلك صدر الأمر الملكي بتاريخ 20/4/1440 بإنشاء هيئة باسم هيئة المحتوى المحلي والمشتريات الحكومية بهدف تنمية المحتوى المحلي بكل مكوناته على مستوى الاقتصاد الوطني. يا ريت تعطينا شرح عن أدوار الهيئة، الأعمال اللي تقوم فيها، وتحديدا في اللوائح التي سنتها الهيئة في ناحية التفضيل في المنافسات والمشتريات الحكومية.
بكل سرور. بداية شاكر لكم الاستضافة الكريمة في المؤتمر الدولي الثالث لمنتجات النخيل والثانوية وتطبيقاتها، وصبحكم الله بالخير جميعا. طبعا إذا نرجع بس نقطة إلى الوراء نشرح مفهوم المحتوى المحلي التي تعمل عليه هيئة المحتوى المحلي. المحتوى المحلي الذي نعمل عليه هو مؤشر اقتصادي يقيس بشكل مبسط الإنفاق الداخلي مقابل الإنفاق الخارجي. آلية العمل والوصول إلى هذا المستهدف تتم من خلال الأنظمة والتشريعات اللي موجودة التي تدعم العمل للوصول إلى رفع نسبة المحتوى المحلي. يخدم هيئة المحتوى المحلي وجود لائحة في نظام المنافسات والمشتريات الحكومية مسماها لائحة تفضيل المحتوى المحلي للمنشآت الصغيرة والمتوسطة والشركات المدرجة في السوق المالية. طبعا اللائحة هذه تحتوي على عدد من الآليات التي تخدم الهدف الرئيسي في وضع متطلبات المحتوى المحلي في المنافسات الحكومية في العقود. واليوم أيضا وصلنا إلى أنه أيضا تطبق مفهوم المحتوى المحلي على الشركات المملوكة للدولة، كلها سعيا إلى الوصول إلى رفع نسبة المحتوى المحلي. إذا أتينا للتعريف فهو قياس الإنفاق على عناصر، نعد العناصر هذه من الخدمات والسلع. طبعا الخدمات والسلع، اليد العاملة، التدريب والبحث والتطوير، وأيضا إهلاك الأصول. كل ما ينفق في هذه العناصر يعد محتوى محلي وإنفاق على المحتوى المحلي. فما تسعى إليه الهيئة هو تعزيز مفهوم المحتوى المحلي في المنافسات الحكومية من خلال آلياتها. من ضمن الآليات الرئيسية التي أعتقد أنه جدير ذكرها هنا هي القائمة الإلزامية للمنتجات الوطنية. القائمة الإلزامية للمنتجات الوطنية هي قائمة بالمنتجات التي يوجد لدينا شروط لإدراج تلك المنتجات في هذه القائمة. من ضمن الشروط وجود عدد من المصانع المحلية التي تنتج هذه المنتجات، ويكون العرض الموجود كافي للطلب الحكومي، وأيضا جودة، التأكيد على الجودة والتأكيد على السعر. كل هذه العناصر توضع كشروط لإدراج المنتج في القائمة الإلزامية، وبالتالي تدرج هذه القائمة ضمن عقود المنافسات الحكومية، ويكون المقاول يعمل على شراء هذه المنتجات من مصنعين محليين. فبالتالي نرى أنه هذا العمل هذا أو الآلية هذه لها دور رئيسي في تعزيز وجود المصانع المحلية، تعزيز الدور اللي تقدمه المصانع المحلية، ووضع خطة للتحسين أيضا المستمر في هذا الدور.
فعلا، وهذا الدور التمكيني الواضح للجهات الحكومية خصوصا للمنتجات المصنعة محليا. الآن ننتقل للمحور الثالث والمتعلق بالبنية التحتية والمساحات الملائمة وتمكين القطاع الخاص في الصناعة. أرجع لك مهندس مصلح للحديث أكثر عن دور وزارة الصناعة والثروة المعدنية في توفير البنية التحتية والمساحات الملائمة للصناعة وتسهيل التحديات والعمليات الإنتاجية في ذلك. تفضل.
طبعا يعني وزارة الصناعة من خلال المنظومة تقوم بدور كبير في دعم الاستثمار في القطاعات الصناعية وقطاع التمور تحديدا عن طريق منظومة متكاملة. حمر على المنظومة هذه كجهة. نبدأ مثلا بالمركز الوطني للتنمية الصناعية، وهو بيت الخبرة يدعم المستثمر في توفير الدراسات، دراسة القطاع، المستهدفات، توضيح للمستثمر رحلة الاستثمار وجميع البيانات اللي يحتاج لها، بحيث أنه المستثمر تتحول فكرته هذه من فكرة إلى فرصة استثمارية واقعية. ومتى ما بنيت بالشكل الصحيح ننتقل للمرحلة اللي بعدها عن طريق توفير البنية التحتية، سواء في مدن عن طريق أكثر من 36 مدينة صناعية أو عن طريق الهيئة الملكية للجبيل وينبع. وحاليا يعني تحديدا لأهمية القطاع الأغذية والتمور بشكل خاص، يعني من ضمن قطاعات الأغذية أنشئت مدينة صناعية غذائية خاصة في منطقة جيزان، أطلقت في الأسبوع الماضي في منتدى جيزان الاستثماري. ننتقل بعدها إلى الصندوق الصناعي بالتواعد مع الصندوق الزراعي، كثير من المحفزات سواء لرأس المال العامل أو إلى تجهيزات المصانع. ننتقل بعدها إلى بنك الاستيراد والتصدير، يساهم، وأعتقد أنه هذه أداة ممتازة جدا لصناعة التمور، توفير الضمانات والتمويل للتصدير لخارج المملكة وفتح أسواق جديدة، خاصة أن القطاع لا يعاني من الإنتاج، ولكن هو قطاع بحاجة إلى الانتقال إلى مرحلة للصناعات التحويلية. وشفنا الجلسات السابقة كان كل الحوار عليها، فالحمد لله المملكة ما تعاني من الإنتاج. مع الزملاء في المركز الوطني للنخيل والتمور في تكامل كبير جدا في دعم هذا القطاع من ناحية سواء تطوير الفرص أو تهيئة البيئة الاستثمارية أو المساعدة في التصدير عن طريق الهيئة هيئة تنمية الصادرات. فاليوم الحمد لله يحظى القطاع هذا بدعم كبير جدا. التكامل لله الحمد متوفر وموجود، ويسهل كثير سواء على المستثمرين في الدخول للقطاع. واعتقد أن وجود الجمعيات يعني الأكاديميين المختصين في هذا المجال يساعدنا كثير جدا في تطوير القطاع والتحول من مرحلة الإنتاج إلى مرحلة الصناعات التحويلية.
يعطيك العافية. فعلا ذكرت نقطة مهمة جدا هي التصدير، وهذا المحور الرابع إن شاء الله راح يكون في الجلسة. دائما التسويق والتصدير يعتبر للمستثمرين والمصنعين تحدي كبير، فودي أسمع من الجميع عن مشاركات الجهات الحكومية في هذا المجال. أبدأ معك أستاذ مهندس ناصر، تبين لنا الجهود اللي تقوم بها المركز الوطني للنخيل والتمور، خصوصا أن عندكم بلاتفورم للمنتجين والمصنعين في تسويق منتجاتهم. تفضل.
بالضبط. المركز أو التسويق هو من أحد الركائز الرئيسية في العمل المركز. المركز عنده أكثر من مبادرة في عملية التسويق والتعريف بالتمور ومشتقاتها. منها أطلقنا منصة تمور السعودية للتجزئة، هي منصة عرض ما بين تعرض فيها المنتجات السعودية لسهولة وصول المستهلك هذه المنتجات. تمثل في هذه المنصة أكثر من 25% منها منتجات تحويلية. ومن كذلك من الأنشطة الأخرى اللي هي المشاركات الخارجية في المحافل الدولية. شارك المركز خلال هذا العام في 7 معارض دولية في عدة دول مستهدفة للتمور، استفاد منها أكثر من 40 شركة. في جانب التصدير عملنا مسار سريع للتسهيل عملية التصدير المنتجات الحاصلة على علامة التمور السعودية المضمونة جودتها، بحيث أن تخلص إجراءات تصديرها خلال أقل من يوم واحد. كذلك من المنصات الإلكترونية هي منصة إن شاء الله قريبا بتطلق، هي منصة تمور السعودية بالجملة، هي الربط ما بين المستورد والمصدر بحيث أنها تضمن عملية البيع وتضمن جودة المنتجات الخارجة من المملكة.
جميل جدا. أستاذ حسن، كذلك للهيئة أدوار يعني عدة في مجال التصدير وفتح الأسواق العالمية للشركات الوطنية في مجال التصنيع، فيلت تبرز لنا بعض الأدوار والمشاركات اللي قامت الهيئة في دعم هذا المجال، خصوصا أن لكم تعاون كبير مع هيئة التجارة الخارجية وهيئة تنمية الصادرات والجهات الحكومية الأخرى. تفضل.
صحيح. زي ما تفضلت أخوي عبد الله في البداية، أنه العمل تكاملي ما بين الجهات ذات العلاقة، خاصة في موضوع زيادة الصادرات من المملكة العربية السعودية إلى دول العالم. واحدة من المستهدفات في الهيئة العامة للغذاء والدواء هو تحديث المواصفات واللوائح الخاصة بالتمور لحل جميع التحديات الخاصة بمصنعي التمور، ولكي تنافس هذه المنتجات في الدول الأخرى تحديداً. واحدة من الأشياء المهمة اللي نعمل عليها في الهيئة العامة للغذاء والدواء هي الشهادات الصحية التي تمنح للإرساليات التي تصدر من المملكة العربية السعودية إلى دول العالم، وخاصة الدول التي تتطلب بعض المتطلبات الخاصة مثل الاتحاد الأوروبي ودول أمريكا وكذلك بعض الدول الآسيوية. فالعمل مستمر في تحديث المواصفات، العمل مستمر في حل جميع العقبات التي تواجه المصنعين المحليين لتسهيل عملية تصدير المنتجات أو تصدير التمور المعبأة تحديداً إلى دول العالم.
ونثني كذلك مشاركة الهيئة في منظمة الكودكس، واللي أسهمت كثير في الاعتراف بالمنتجات الوطنية في الأسواق العالمية.
صحيح.
أرجع لك أستاذ خالد، يعني ذكرت نقطة جدا مهمة من ناحية اللائحة التفضيلية، وأذكر أن لديكم كذلك قائمة في هذه المنتجات، وهذا جانب من تسويق تلك المنتجات للمشتريات الحكومية والمنافسات.
صحيح. طبعا مثل ما ذكرنا سابقا المعذرة، مثل ما ذكرنا سابقا قائمة المنتجات الوطنية، القائمة الإلزامية للمنتجات الوطنية تلعب دور غير مباشر في التسويق للمنتجات المحلية، ولكن العمل يتم من خلال مثل ما ذكرنا فيه شروط أساسية لإدراج تلك المنتجات في القوائم ذاتها. القوائم اليوم تغطي أكثر من 12 قطاع، وصل عدد المنتجات اليوم إلى أكثر من 800 منتج. طبعا لغة الأرقام هي الأساسية اليوم، نحاول أن نسلط الضوء على لغة الأرقام لتتضح الصورة. كل منتج من هذه المنتجات يوجد لدينا أسماء لمنتجين أو مصنعين محليين، فبالتالي كل منتج من هذه المنتجات يوجد لدينا على أقل تقدير، وهي أدنى حد للشروط 3 مصنعين محليين، وإن كان هناك أكثر فستجد أنه أكثر من مصنع محلي موجود مدرج في تلك القائمة، مصادر المعلومات الاتصال لسهولة الوصول إلى المصنعين. طبعا القوائم والمسميات الشركات ليست شاملة، فبالتالي يوجد أكثر من هذه الشركات، ولكن هذا ما تم العمل عليه. اليوم إن كنا نتكلم عن القوائم الإلزامية فإجمالي الصرف عليها في عام 2022 تعدى 26 مليار ريال سعودي، وهذا إنفاق محلي. أثره الاقتصادي تعدى 10 مليارات ريال سعودي، فبالتالي يوجد أثر قياسا في المنتجات الوطنية وعمل القوائم الإلزامية، ونسعى لتحسين ذلك والوصول إلى مستويات أعلى بإذن الله.
ما شاء الله، أرقام جدا جميلة وتعطي اطمئنان كبير لهذه الصناعة وللمستثمرين في المجال. ننتقل للمحور الخامس، وهذا ما يخص ضمان وسلامة المنتجات. أستاذ حسن، عندما تطرقت في سن التشريعات، سن التشريعات تهتم لسلامة وجودة المنتجات، وأعلم كثيرا أن هناك جزء يعني رقابي وجهد رقابي من الهيئة العامة للغذاء والدواء لضمان هذه المنتجات وسلامتها. فودي تعطينا تصور خصوصا عن البرنامج اللي ذكرته، البرنامج داعم، شو الأدوار اللي تقوموا فيها في هذا المجال؟
طبعا الدور الأساسي هو لضمان سلامة ومأمونية المنتجات الغذائية في المملكة. واحدة من أهم الأذرع هي الجولات التفتيشية التثقيفية، ليست هي جولات تفتيشية رقابية، وإنما جولات تفتيشية تثقيفية للمصنعين المحليين للتأكد من التزام بتطبيق الاشتراطات واللوائح ذات العلاقة. في حال وجود تحدي هناك فريق مخصص في الهيئة العامة للغذاء والدواء، هذا الفريق دوره هو زيارة المصانع التي تواجه تحديات، سواء في تطبيق بعض اللوائح، سواء في الالتزام في بعض الحدود سواء الميكروبية أو الكيميائية لضمان سلامة ومأمونية المنتجات الغذائية. طبعا فريق داعم هذا دوره الأساسي هو دعم الصناعة المحلية، حل أو تذليل جميع العقبات التي تواجه المصنعين تحديدا، سواء في الحصول على الترخيص، في العملية التصنيعية نفسها، أو في تصدير المنتجات لخارج المملكة العربية السعودية.
جميل جدا. أرجع لك مهندس ناصر، ذكرت علامة التمور، ومن متطلبات الحصول على علامة التمور أن يكون المنتج ذات جودة عالية ومأمونية، فودي تشرح لنا وش متطلبات هذه العلامة ودور المركز في تحقيق الجانب الجودة والسلامة.
ممتاز. في جانب الجودة أو أهمية الجودة، المركز في عام 2018 أطلق علامة التمور السعودية. العلامة هدفها هي ضمان جودة سلامة المنتجات وأيضا العمليات التي تقوم على عملية الإنتاج. تمنح العلامة لثلاث فئات هي المزارع، المصانع والشركات، بعد الامتثال لتطبيق المعايير اللي هي أساسها معايير سلامة الغذاء وأيضا الممارسات التصنيعية الجيدة. تمنح العلامة بعد زيارة للمنتجين، تحقق من مطابقة المتطلبات الموجودة، وأيضا من سلامة المنتجات بعد تحليلها من ناحية الميكروبيولوجية ومن ناحية متبقيات المبيدات. على أثر ذلك تمنح العلامة. كذلك الشق الثاني في العلامة اللي هي تعزيز تطبيق المواصفات القياسية للتمور، بحيث أن الحاصل على العلامة يعمل على عملية التصنيف المعتمد لدى المملكة العربية السعودية في تصنيف التمور إلى ثلاث فئات.
جميل، جميل جدا. ذكرت أنه عندكم منصة للتسويق، وكذلك تعملون على تثقيف المزارعين والمنتجين. بالأمس عملت بحث سريع في الموقع الخاص بالمركز، ووجدت أن هناك أكاديمية إلكترونية مخصصة للتدريب، وهذا المحور يعتبر المحور السادس لنا في الجلسة. فبودي تعطينا تصور عن هذه الأكاديمية، أدوارها والبرامج اللي تشملها في الأكاديمية. تفضل.
هي أكاديمية إلكترونية للنخيل والتمور. هدفنا فيها اللي هو رفع الوعي لدى المزارعين وتدريبهم في تطبيق الممارسات الزراعية الجيدة اللي تساهم في رفع كفاءة الإنتاج وأيضا تقليل تكلفة الإنتاج. الأكاديمية فيها 5 دورات رئيسية. كل دورة طبعا تبدأ من عملية، أو ال5 دورات تتضمن العمليات من إنشاء وتهيئة المزرعة إلى عملية الحصاد والتخزين. المتعلم أو المزارع أو المهتم اللي بيدخل هذه الأكاديمية بيكون عنده معرفة شاملة عن أغلب العمليات اللي تساعد في تحسين العملية الزراعية. كذلك حاليا نعمل على تحسين المحتوى وزيادة المحتوى لإضافة فئات مستهدفة أخرى اللي هو القطاع الصناعي. فإن شاء الله على السنة القادمة إن شاء الله أنها بتكون موجودة متضمنة في الأكاديمية.
جميل، جميل جدا. أستاذ حسن، نرجع لك مرة أخرى. للهيئة دور كبير في التدريب، ويعني ورش العمل التي طرحتها الهيئة خصوصا في سن التشريعات وأخذ الآراء والمرئيات في هذه السياسات والتشريعات. فبودي تعطينا تصور والحضور كذلك عن هذه الأدوار والورش العمل ومدى تأثيرها في هذا المجال.
طبعا مؤخرا دشنت الهيئة العامة للغذاء والدواء أكاديمية مخصصة لتثقيف المصنعين في ذات العلاقة سواء من الدواء أو الغذاء أو الأجهزة الطبية. هذه الأكاديمية عندها مستهدفات سنوية تتمحور حول تقديم ورش عمل لجميع المصنعين وكذلك المستوردين أو المصدرين لخارج المملكة. تتمحور هذه الورش في طرح التحديات، حل بعض التحديات، وكذلك تثقيف العملية التصنيعية بشكل كامل.
جميل. كذلك أستاذ خالد، لاحظت كذلك في البحث السريع عن دور هيئة المحتوى المحلي، وجدت أن ورش عمل تقومونها بشكل أسبوعي. صحيح. وموجهة للجهات الحكومية والقطاع الخاص. فودي تعطينا التصور والتوجه هذا، هل كان له جدوى كبير؟ يعني إيش تصوركم من ناحية هذا التثقيف خصوصا في مجال المحتوى المحلي وتثقيف الجهات الحكومية فيه؟
أكيد. طبعا مثل ما ذكرنا سابقا، طبعا إذا رجعنا إلى الوراء قليلا، لائحة تفضيل المحتوى المحلي دخلت حيز التنفيذ في بداية عام 2020، نهاية عام 2019 بداية عام 2020. فبالتالي أخذت الهيئة على عاتقها تثقيف الجهات الحكومية في آليات المحتوى المحلي وكيفية التطبيق ومراعاة التشريعات اللي موجودة فيها. ومن تلك السنوات إلى اليوم يوجد لدينا اليوم مركز تميز خاص يقوم بعملية إقامة دورات للقطاع العام والقطاع الخاص لتعزيز مفهوم العمل بالآليات للوصول إلى الأثر الرئيسي من تعزيز المحتوى المحلي. فبالتالي عملية التطبيق الصحيح التي تتم على العقود الحكومية والعقود الشركات المملوكة للدولة، وأيضا من قبل المقاولين العاملين على تلك العقود، يعزز من يعزز المحتوى المحلي والوصول إلى المستهدف الرئيسي. خلال هذا العام أقيمت أكثر من 400 ورشة عمل للقطاع العام والخاص لتعزيز مفهوم المحتوى المحلي والعمل بآلياته وتشريعاته.
جميل جدا، خصوصا أني لاحظت كذلك أن هناك جائزة
نعم
للمحتوى المحلي، وأكيد أن ورش العمل تكلت بالنجاح
نعم
بمنافسة الشركات والجهات الحكومية للحصول على الجائزة.
نعم إذا سمحت لي، طبعا الجائزة شيء جميل تم العمل عليه للوصول إلى التميز في أعمال المحتوى المحلي، فبالتالي نجد اليوم الجهات الحكومية تتنافس على هذه الجائزة. أيضا يوجد مسارات للقطاع الخاص وللشركات المملوكة للدولة للعمل للوصول إلى تلك الجائزة، وهذا يساعدنا أيضا في عمليات التقييم في الوصول إلى المفهوم الرئيسي وتعزيز مفهوم المحتوى المحلي في المشتريات بشكل عام، وهذا ما يساهم بشكل رئيسي للوصول إلى مستهدف تعزيز المحتوى المحلي على المشتريات بشكل
جميل جدا، ويساعد كذلك في دعم وتنمية
أكيد
الصناعة المحلية. ختاما أنتقل لك مهندس مصلح المحور السادس والأخير في هذه الجلسة، وهو الجهود في توطين التقنيات والابتكار. أعلم أن هناك مبادرات عدة من وزارة الصناعة والثروة المعدنية، فودي أنك تشارك الجميع هذه المبادرات خصوصا في مجال توطين التقنيات والابتكار.
طبعا بداية يعني في ناخذها تحديدا في الاستراتيجية ثم ننتقل للجهود. الاستراتيجية فيما يخص قطاع التمور فيها مبادرتين بقيمة تتجاوز النصف مليار ريال جاري العمل على التجهيز لها. هذه المبادرتين تركيزها بشكل كبير جدا على الابحاث والابتكار وادخال التقنية الحديثة في عمليات التصنيع والتطبيقات التحويلية. الميزة صراحة التنافسية في النخيل والتمور انه لو اخذناها كتطبيقات أغذية فرص فيها كبيرة جدا، لو اخذناها تطبيقات بيئية وخاصة مع التحولات والتغير المناخي والتزام المملكة، تطبيقات جدا كبيرة وضخمة فرصة انه يبدأ العمل عليها. لو اخذناها في تطبيقات الصناعات التحويلية ايضا يعني شيء ضخم جدا. والموقع انا دخلت جامعة الملك سعود، يعني كمية الأوراق العلمية في هذا المجال شيء كبير جدا. فاليوم هي فرصة انه من خلال هذه المبادرات اللي موجودة في وزارة الصناعة انها تتحول من دراسات الى تطبيقات عملية فعلية، خاصة انها مدعومة برغبة حكومية كبيرة جدا للاستفادة من جاذبية هذا القطاع. فيما يخص التوطين والتقنيات الحديثة، الوزارة طبعا عندها مبادرة التحول لمصانع المستقبل واستخدام التقنية والأوتوميشن والتركيز على الأيادي العاملة ذات الكفاءة العالية عن طريق عدة يعني برامج. والشيء يعني الجميل لهذا القطاع انه وجود معهد الصناعات الغذائية ونجاحه الكبير جدا في توفير أيادي عاملة بمهارة قادرة على إحداث هذه النقلة، سواء في عمليات التشغيل أو في عمليات الإنتاج أو عمليات الفحص والجودة. أيضا اللي يدعم هذا كله يعني سواء في التقنية، إنه اليوم سهل جدا الوصول للجهات الحكومية. أيضا التكامل الكبير اللي ما بين هذه الجهات الحكومية يساهم إنه ما يكون في تشتت سواء للمستثمر أو للباحث. يعني اليوم احنا ما بنركز على المستثمرين فقط بحكم وجود قامات علمية، أيضا الوزارة أبوابها مفتوحة لجميع الباحثين، لأنه الأصل في التطور وخلق الميزة التنافسية هي الأبحاث والابتكار. وهذا الشيء صراحة اللي وجدته في زيارتي للموقع وحضوري للجلستين السابقة لهذه الجلسة. فهي فرصة أنه من خلال هذا المنبر توطين المعرفة، توطين التقنية يبدأ بالبحث والابتكار. والجمعية هذه وكلية وجامعة الملك سعود والدكاترة الأفاضل اللي موجودين هم خير معين بإذن الله للوصول لهذه المرحلة.
فعلا أثني على آخر ما ذكرته من ناحية أن البحث العلمي هو الوسيلة لهذا التمكين ولخلق الفرص على أرض الواقع،
خاصة قطاع يعني من القطاعات القليلة اللي ما يعاني من مدخلات الإنتاج. صحيح. متوفرة مدخلات الإنتاج والحمد لله، باقي كيف نحولها إلى صناعات تطبيقات سواء كانت تحويلية بيئية غذائية. هذا إن شاء الله من نتائج هذا المؤتمر اللي احنا فيه بإذن الله.
بإذن الله. في نهاية الجلسة إذا كان أي سؤال من الحضور اتفضل.
السلام عليكم. شكرا جزيلا لكم منظمين أيضا. أخوكم عبد الله بن محمد الحمدان، المشرف على كرسي تقنيات تصنيع التمور بجامعة الملك سعود. حقيقة نقاش ثري جدا، ونشكر الإخوة المتحدثين عن التمور وهمومها وأيضا الأنظمة الخاصة بها. في الآن لو نظرنا إلى قطاع التمور بشكل عام في المملكة نجد أنه قد يوصل إلى حدود 200 مصنع مثلا للتمور، وهذا صراحة شيء جدا مفرح، تقدم بشكل كبير في السنوات الأخيرة. جل هذه المصانع طبعا كما نعلم مصانع تعبئة، وإن كانت بدأت في الصناعة التحويلية بشكل يعني معقول، ولكن يمكن نحتاج إلى خطوات أكبر في تسويق هذه المنتجات. يمكن لو شفنا معرض نلقى العشرات من المنتجات التحويلية تحتاج بالفعل إلى التسويق بشكل المناسب سواء محليا أو تصدير. هذا الجانب الأول. إذا سمحت لي لها جانب آخر، لو نظرنا إلى محور هذا المؤتمر نجد أن عن الصناعات المنبثقة من منتجات النخلة الأخرى أو متبقيات النخلة الأخرى، فنجد أن في المملكة أو في المنطقة بشكل عام ليس هناك مصانع حتى الآن تجارية بالمعنى المتعارف عليه. يمكن نوقش هل هو لها جوانب اقتصادية، جدوى اقتصادية، تجميع، مشاكل تقنية، لوجستية إلى آخره. فأنا يعني بهذا القطاع الحكومي المتميز أنه ممكن تصير مبادرة مثلا من الدولة حفظها الله في خاصة من رؤية 2030 أنه يصير في مبادرة حكومية لتبني مثل هذه المشاريع، مشروع ضخم أو مشروع رائد، فبالتالي ممكن المصانع الأخرى أو للمستثمرين الآخرين الشروع في هذا المسار. فهذه يعني النقطة الثانية. آخر نقطة إذا سمحت لي أيضا أستاذ حسن، بالنسبة لي الآن مصانع تمور أو مصانع الأغذية بشكل عام هي تحت إشراف الهيئة العامة للغذاء. جميل. بس عندي استفسار عن المعامل. يعني نزرنا عدة معامل من خلال عدة زيارات ميدانية، ففيه كثير أيضا من المعامل في مختلف مناطق المملكة الغذائية، فهل هناك يعني تعليق حولها؟ وشكرا.
الله يعطيك العافية طبعا على هذا السؤال. فيما يخص المعامل بالتحديد، طبعا احنا والزملاء في وزارة الشؤون البلدية والقروية راح تتحول هذه المعامل إلى مصانع. لن يكون هناك في المستقبل القريب ترخيص لمعمل غذائي، راح يكون منفذ بيع أو مصنع متكامل في منطقة صناعية يقوم بعملية تصنيعية كاملة يطبق كافة الشروط التي تضمن سلامة ومأمونية المنتجات الغذائية. في معامل قد بعض الأحيان المساحة أو ضيق المساحة تحد من عملية ضمان أو سلامة منتجات الغذائية، لذلك توجهت القطاعات ذات العلاقة بدعم هذه المعامل الصغيرة إلى التحول إلى مصانع بحيث أنها تكون منتجاتها سليمة ومطبقة للاشتراطات.
يعطيك العافية دكتور عبد الله.
بس عندي أنا على النقطتين اللي ذكرها الدكتور فيما يخص التسويق والاستفادة من مخلفات النخيل. يعني صراحة لما تيجي الملاحظة من الدكتور بقامتك تعطينا مؤشر إنه إحنا في الطريق الصحيح، خاصة إنه فعلا يعني في واحدة من المبادرات هو التسويق العالمي للتمور ضمن الاستراتيجية الوطنية للصناعة، ومسؤول عن تنفيذها المركز الوطني للنخيل والتمور، ويعطيك يعني حجم التكامل. أيضا يعني هيئة تنمية الصادرات تنسيق كبير جدا مع المركز الوطني للنخيل والتمور، وأحد أعضاء مجلس إدارة هيئة تنمية الصادرات هو الرئيس التنفيذي للمركز النخيل والتمور. ففي تركيز كبير جدا من الدولة على هذا الجانب، وبإذن الله يعني الأرقام في تصاعد، وهذا اللي جالسين نلاحظه. حتى يعني لما نسافر ما كان يتواجد بشكل كبير، اليوم الحمد لله موجود. فيما يخص الاستفادة من مخلفات النخيل، فعلا يعني برضو أيضا مبادرة ثانية على الاستفادة مما قبل الإنتاج، وليس التركيز على الثمرة فقط اللي هي التمر. هذا أيضا مع الزملاء في المركز الوطني للنخيل والتمور والمركز التنمية الصناعية ضمن الاستراتيجية الوطنية للصناعة، هي المبادرة الثانية اللي تركز على ما قبل الثمرة إلى يعني إلى المائدة، إلى يعني فعلا في فرصة كبيرة جدا في التطبيقات البيئية للاستفادة من مخلفات النخيل. فهذه إن شاء الله أنها جالسة تدرس. والشيء اللي يعني مريح لنا في القطاع وجود الكرسي في جامعة الملك سعود، فيعطينا يعني تصور واضح للوضع الراهن، وبإذن الله أنه نكون استمرار للأعمال اللي قمت فيها، وننتقل إلى مرحلة تطويرية ضخمة بإذن الله تتواءم مع رؤية المملكة 2030
بإذن الله. سؤال آخر.
السلام عليكم ورحمة الله. عبد الغني الأنصاري. عندي 3 أسئلة بشكل سريع. الإخوان في المحتوى المحلي اليوم لما نشوف الجوائز اللي بتوزع هي من منتج دولة أخرى في كوكب آخر، كنت أتمنى أن تكون هذه الجائزة اللي توزع من منتجات النخيل. إذا هنا أنا أؤمن أن أنا عندي في النهاية دعم، بستفيد من الطاقة، بدل كل فجر اليوم بيحرق هذا المنتج بعد صلاة الفجر في كل المزارع بلا استثناء. السؤال الثاني يا إخوان، في مركز النخيل والتمور أرجو أن نشاهد منصة مشابهة لأمازون وعلي بابا اسمها أمازون التمور، علي بابا التمور. هذا هو الدور اليوم. أنتم الدولة الأولى المصدرة رقم 1 في العالم اللي تحمل كنز التمور. لا يوجد ترى دولة في العالم عندها تنوع التمر الموجود عندكم، زي اللي عنده جواهر ومحطوطة في الدرج. ما ينفع، الناس لازم كلها تدخلوا كل أسواق العالم بدون استثناء. السؤال الثالث يا إخواننا، في الصناعة اليوم إذا تبغاني أنا كصاحب شركة أبدع، يجب أن أجد خارطة طريق ما هي الصناعات الصغيرة اليوم المجدية اللي تعطي قيمة مضافة للبلد، والمتوسطة والكبيرة. اليوم أشبعنا من قضية حشو تمرة وتغليف تمرة، انتهينا الكلام ده. يجب اليوم نجي إلى شيء قيمة مضافة، إلى نصل إلى موضوع خطير ترى بين قوسين، التمر هو أمننا الغذائي. هل سنستمر نحول كله إلى صناعة، وإلا نقف عند 30 40 50%؟ هذه هي المؤشرات المهمة. شكرا.
الله يعطيك. طيب بداية الله يعطيك العافية، شاكر ومقدر سؤالك. طبعا عطفا على الإجابة، عشان أجيب على سؤالك عن ناحية الجوائز، أتكلم لك على نقطة رئيسية. حنا مفهومنا طبعا كهيئة للمحتوى المحلي تنظر للاقتصاد بشكل عام، فبالتالي القطاعات كافة يتم النظر إليها والعمل معها جنبا إلى جنب. إذا أردنا تعزيز العمل في قطاع النخيل ومنتجات النخيل وما يترتب عليه من التطبيقات الأخرى، فتحرك القطاع الصناعي يخدم الهيئة في دعم هذا القطاع. العمل الرئيسي الذي نقوم به اليوم هو دعم ما هو موجود، دعم المصنعين المحليين، العمل على زيادة أو توجيه الإنفاق نحو المصنعين المحليين، وكل هذا يتم من خلال وجود صناعة قابلة للعمل والتوسع والوصول. فهذه أكاد أجزم بإذن الله أننا من خلال العمل، طبعا الهيئة جديدة، الهيئة يمكن عمرها اليوم 4 سنوات، ولله الحمد والمنة الأثر الذي تقدموا به اليوم يقاس بأنه في أثر إيجابي على المصانع وعلى المنتجين المحليين. يوجد تحديات، هذا شيء طبيعي. العمل الرئيسي أو النقطة الرئيسية التي يجب علينا العمل فيها هو التحدث عن هذه التحديات والعمل على إصلاحها وتخطيها. فسعيد جدا بطرحك، وبإذن الله نكون آذان صاغية للوصول لحلول مستمرة بإذن الله.
مهندس ناصر، بخصوص السؤال الأستاذ الأنصاري بخصوص منصة التسويقية.
تمام، شكرا لسؤالك. المركز بالفعل أطلق بداية هذا العام منصة التمر السعودية، هي منصة بيع بالتجزئة داخليا وخارجيا، فهذا هو هدفها إن شاء الله. فأي منتج أو أي مصنع يقدر يعرض منتجاته من خلال هذه المنصة وتوصل لأي دولة كانت.
وذكرت كذلك إن في منصة أخرى متعلقة بالجملة، وهذه أكيد تعطي خيارات أخرى للمصنعين، مو فقط المنتجات النهائية بشكلها، ممكن يكون منتجات بشكل جملة وتوصل الأسواق يعني بشكل أسرع وبأقل تكلفة بإذن الله. السؤال الأخير بخصوص
جزئية الصناعة. طبعا يعني ما يخفى على الكل قطاع الأغذية في المملكة العربية السعودية ما قبل كورونا وما بعد كورونا، الدعم الحكومي والحراك من كل الجهات الحكومية ما بعد كورونا فيما يخص الغذاء صار بمنظور مختلف. دائما الموجه لنا في هذا القطاع هو الأمن الغذائي. بعد ما يتحقق الأمن الغذائي ننتقل للصناعات التحويلية، وهذا الشيء تضمنته الاستراتيجية الوطنية للصناعة. أول يعني هدف الأمن الغذائي، بعدها الانتقال للأمور الأخرى. فيعني أطمنك أنه الأمن الغذائي هو الأولوية، لأنه هذه سلعة أساسية وسلعة هامة، والحمد لله تنتج بأقل مجهود، فلا يمكن التفريط فيها. التركيز هو بيكون في بداية على مخلفات النخيل والأمور هذه كلها، وفي تحديدا في تطوير الفرص. أيضا يعني بتنطلق مبادرة في تطوير الفرص الاستثمارية في قطاع الأغذية، بتدخل إلى الفرص. يعني الفرص اليوم اللي قائمة خلاص، معمولة التمر، الحشو، هذه خلاص فرص قامت، فلن نكرر يعني أعمال سابقة، لا بنبحث عن فرص حقيقية غير يعني مركز عليها، وأيضا معها حقبة من الحوافز اللي تدعم البدء فيها بإذن الله.
بإذن الله. سؤال أخير، تفضل.
السلام عليكم. عبد الرحمن الكريدة، شكرا لكم. مداخلتين أو سؤالين بسيطين. الأول، أستاذ مصلح يقول مخلفات النخيل، وهذه الجملة تجعلنا في مربع لا نتقدم. إحنا لا نطلق عليها مخلفات، لو هي مخلفات لا يمكن أن أعيد تدويرها ثاني مرة أو أستفيد منها. فربما الدكتور عبد الله عقب عليها كثير، أو البروفيسور عبد الله بكثير من المقالات. مصانع التمور لها العديد من الجهات المرتبطة فيها، من أنشأت تحت مظلة وزارة الصناعة، ثم التصريحات من هيئة الغذاء والدواء، ثم دعم من وزارة التجارة في المشاركات، والأب الروحي والداخلي هو المركز الوطني للنخيل والتمور. اليوم مصانع التمور يطبق عليها شروط وزارة الصناعة القائمة عندها محددة للمصانع، ربما لا توافق أو اشتراطات لا توافق مصانع التمور. لابد أن تكون هناك جهة معينة ما يتعلق في مصانع التمور. الأمر الثاني، إنشاء الجمعيات الأهلية الغير ربحية لمصانع التمور عديدة، والآن حنا بصدد إنشاء جمعية خاصة لمصانع التمور. الآن أي جهة ممكن أن تربط هذه؟ أنا كمصنعي من هي الجهة التي أروح لمها؟ جهة واحدة. إذا كانت وزارة الصناعة وألقى الدعم من المركز الوطني فخلاص أنا أتابع مع وزارة الصناعة. هذا شق. الشق الآخر، اليوم صناعة المنتج، حنا نحاول أن نطور سكر التمر ومنتجات كثيرة. من دون ما ندري السوق الأوروبي أو السوق الخارجي والشيء، يعني أنا يسحب من السوق، هو اللي يفرض علي ماذا يريد. اليوم العالم كله يمكن يوافقنا ويخالف الأصاري ومجموعة أن العالم يبي التمرة كما هي، حتى النوى أو العبس اللي داخلها لا تشيلها، عطني حتى الغبار اللي عليها يقول لك لا تنظفه بعض الدول. فأنا السوق هو اللي يطلب منا، السوق العالمي هو اللي يطلب منا. خلينا نمشي بهذا التوجه، ماذا يريد منا السوق العالمي حتى أعطيهم منتجي. شكرا لكم.
Okay, thank you so much.
الله يحييك. طبعا أنا والله دلوني على الاسم الصحيح، الواحد يتعلم يعني في إيش الاسم بدل المخلفات إيش بقايا. طيب الواحد يتعلم صراحة. الجزئية حقت يعني أنا كنت بتركها للختام، اللي هي جمعية مصنعي التمور. اليوم في المجلس الصناعي وتمثلوا فريق من منتجي التمور. الوزارة الآن تدعم تصنيع جمعيات مصنعي التمور، فلعلها فرصة نتقابل بعد الاجتماع ونرتبها بإذن الله.
لو سمحتوا لي بس على المداخلة.
معليش ضيق الوقت لأننا موجودين، ممكن يعني ضيق الوقت لأن فيه جلسة وفي سؤال قبلك، لكن نرحب بالأسئلة بعد الجلسة، يعني أننا موجودين معكم بإذن الله.
بس هو أمر
اسمح لي الله يحفظك لأن في جلسات أخرى، أعتذر منك. في ختام هذه الجلسة ودنا نعبر شكري للجنة التنظيمية واللجنة العلمية على إعطاء الفرصة للجهات الحكومية المشاركة في هذا المؤتمر، وأشكر زملائي الحاضرين ومشاركاتكم ومداخلتكم في هذا المجال.
Okay, thank you so much for moderator Dr. Abdullah Khalifa for conducting a very good discussion with the panelists. So I'm calling the Dr. Stanford. Please come on the stage to give the token of appreciation to moderator Dr. Abdullah Khalifa. Thank you, Dr. Stanford, for giving a appreciation to Dr. Abdullah. Now I call Professor Ali Hassan again on the stage to give to the Moslef Fayyaz. Thank you, Ali Hassan. Now I call the Khalid, Dr. Usman, Prof. Usman to come on stage to give the token of appreciations to Khalid Fahad. Now I call Prof. Hom Dakal to come on stage to give token of appreciations to Hassan Saleh. Dr. Badawi, I will call after you. Now I call Dr. Badawi to come on the stage to give token of appreciation to Nasir Al-Bishi. On behalf of organizing committee, we are very thankful to the moderator, Dr. Abdullah, and all the panelists for conducting a very good discussion panel too. Now we are moving forward towards the coffee break, and we are going to again meet at 12 o'clock. And we have this is room A, and beside that we have session B1, B3 on room B, and B session C3 in room C. So look forward to you after the tea break. Thank you. It's not working. Now it's coming. Okay. Assalamu alaikum and good afternoon to all of you. So now we are moving forward to our next session. In that we have the 1, 2, 3, 4, 5 speaker. We have that one. So where is Dr. Muhammad Al-Harbawi? Okay, come. So I call that the session chair to come on the stage to take the stage and start this session. Thank you so much. No. This now charged to you. You call them and they will present. No. This is your job because you are session chair. Thank you. You are the boss now.
Assalamu alaikum and good afternoon. Welcome everyone for this afternoon session. I would like to call for first speaker, Mr. Muhammad Munir, to speak about his paper is date palm derived biochar amendment in mitigate water defect effect in the greenhouse grown cucumbers. Please come, Mr. Muhammad.
Assalamu alaikum. This is Muhammad Munir from King Faisal University, Al-Asa. It's a great honor and pleasure being here at this conference. Today, my topic is date palm derived biochar amendments to mitigate water deficit effects on greenhouse grown cucumbers. This is, sorry. Yeah, thank you very much. Thank you. Yeah, so we're going to start the motivation of our project about the biomass recycling and about the biochar. Since yesterday, we have heard a lot of about biomass, which is generated through forestry and agricultural practices. So a lot of biochar is produced through agriculture and forestry cultural practices. And we know the biomass waste, which I learned yesterday that this is not a waste, it's a recycled material, sure. So the biomass recycled material production is around 140 to 146 gigatons per annum, which accounts for a very good 14% of energy consumptions. And agriculture biomass is possibly a foundation material to produce sustainable energy that depends on the type of feedstocks and crops, different material, the leaves and twigs and the stems. For example, rice straw has an energy content of around 13% megajoules per kg, and hay grass around 16 megajoules per kg, and the date palm we have around 14.4% megajoules per kg. Most of this biomass recycled material are left to decompose in the field, which take more time because it contains cellulose, lignin, and all these sort of material which take time to decompose. Or the farmers, the date palm farmers, they just burn it in the field. That cause certain environmental pollution sort of things like carbon dioxide if they burn it, or methane if they leave it to decompose, and nitrous oxide as well, which is a greenhouse potent gas. So we talked about a little bit about biomass, and then the date palm, we're talking about the biomass of date palm. So it is cultivated around 1.25 million hectares worldwide, globally. And its leaves, stems, fruit, bunches, and leaf sheets, seeds, they all are like a leftover material. So it has a great potential to recycle it, to reuse it into different sort of things. So a date palm tree is estimated to produce around 20 kg. I have learned yesterday that it's around 20 to 30 kg per year, dry matters. That is excluded 10% of wasted seeds. Saudi Arabia, we know it produces more than 200,000 tons of date palm waste annually. So there is a lot of potential. This statistic is around 2018. So maybe it is updated to more than that one. So the limited amount of date palm biomass is utilized as a fodder, not 100% like a fodder, but it mixed with some other crop biomass and then used as a fodder, or converted into compost, or a raw material in pulp, paper, and chipboard industries. They use it. So date palm biomass, we know it has cellulose, hemicellulose, lignin, and organic matters, volatile solids and low moisture content. So these property made it very ideal to recycle it. So we knew about biomass, date palm waste, and now thanks to the various thermal and biochemical technologies, they emerged to convert the energy stored in the biomass into its useful form. The thermochemical conversion processes, there are different processes like pyrolysis, like gasification, combustion. These processes are used to produce biochar or synthetic gas and biofuel and many more. Now we come to the biochar. So biochar is produced through pyrolysis. So in a controlled temperature condition, in a furnace or in any prototype material which we have used. I'm going to show you in a minute. So we use this biomass material in an anaerobic condition where oxygen is very limited in the chamber, and the process we use is pyrolysis, which is the thermal decomposition of organic material, where we elevate the temperature, we raise the temperature with a limited oxygen in atmosphere, limited oxygen level. So what we produce, the biochar. So when we produce, it depends on different feedstock available. So if you go through the literature, you will see some material they use around 250 degree temperature, and some material which is very hot, so they increase the temperature and they play with the pH, lower the pH level or EC level. So normally equal or less than 300 temperature. So at that temperature it is reported in the literature that most of the nutrients are like sustained, they are available within the biochar content. And if we increase the temperature equal or above 600 degree Celsius, that reduce the nutrient contents and increase pH as well. But it is not, there is no hard and fast sort of things that we have to play with the material, whichever feedstock we have, and then we see which is appropriate. That's what we have done with the date palm. Well, I think we, since yesterday, we know about that this is a carbonated material, the black, hang on. Yeah, it's a black material. Is this hindering me? It's a, it's a black carbonic material which stay like longer in the soil. It retain micro and macronutrients. And I would show here a quite rosy picture of biochar rather than to say its limitation. There are some, of course, limitations, but I'll just like to show a rosy picture that it has advantages in carbon sequestration, agriculture, and environmental sustainability. So the carbon sequestration, we can sink carbon for a long time in the soil, right? So that is we can mitigate the climatic change. I mean, if it is outside decomposing material, burning it, then it affects the climate. The other thing is that biochar improves soil water. The biggest advantage is water holding capacity. It increases. It retains nutrients, recycling nutrient materials. So improve soil microbial activities. A lot of things they already mentioned yesterday. And highly porous material, we know that it enhances soil fertility. If it is porous, the nutrients sustain within the surface area. The microbial activities, enhance there. So the soil fertility increase. So, and then this is the advantage of date palm biochar. I can assume it. The biochar can use to acidic and highly weathered tropical soils to raise pH, because that question arises like yesterday. Someone asked in room C that, how can we play with its high pH level? So that why if we are not going to reduce any pH, we can use it in acidic soils. Like I would put example here, like British soils, they are more acidic. So I had an experiment there on this zucchini. So we used this material, the date palm material I took from here. I did analysis thanks to Dr. Rafzan Hajuj. So he supported us, and we had done this zucchini experiment there, and acidic soils, because the soil pH is acidic there in Britania climate. Temperate, a lot of rain there, lot of organic matter is there. When there is more organic matter, the soil is acidic, and rainfall as well. So decomposition is very rapid. So this date palm high pH is around 8 plus, 7.8 like this. So if we use it in acidic soil, it is ideal. It reduces the soil, rather increase the acidic pH to the neutralized level. Or we can play it with another way as well. We can mix this material with the organic matter, any organic compost available which is acidic. We can mix it with it, and we can use it for any cultivation. And another thing is, we're talking about the organic material. If another experiment I have done, because this is, we went on the applied side of the because a lot of theoretical studies have done. If we mix it with the animal slurry, even like animal urine that is acidic, so we mix it with the urine. I'm not going to mention the name of the animal. We mix it, and then it improve or decrease the pH. It's neutralized, and that is activated. We activate, made it activation. Activated biochar. We use it. We treat it with the urine. We use it for flower production, like snapdragons, chrysanthemum, and others. So quite few ornamental plants, we use it, and it gives us very good results. So this is the ideal one that we can, it can be used in acidic and high weathered tropical soils, rainfall and all these things. So, or like I said, the next one is the biochar can be used as a soil amendment in mix up with, conjunction with compost. So another organic material or slurry, like I said, with the urine, you mix it up and leave it for a couple of months, and then it will neutralize the pH, or with the fertilizer. So it retains pollutants. We are nearly to have an experiment of this the retention of lead and cadmium and pesticide, heavy metal. These are, they have storage ability. Structure is improved, stability of the nutrient is there, and then it retains nitrogen, like it has a porous spaces. And when it retains nitrogen, that means the nitrous oxide gas is not releasing into the atmosphere. So that means you are going to mitigate the climatic effect as well to some extent. And again, it also retain or reduces the methane gas, because when when the biomass is not going to decompose, when it is decomposed, the methane is released. You are not going to decompose it, so you are going to carbon sequestration for a long time. So you are burning nitrogen for, like in the literature, it's like 1,000 years. You can bury nitrogen like a Amazon forest. They are like for thousands of years, the soil is all black because of these things. Right. So at the end, the biochar, we know that is a simple process, it's a sustainable tool for recycling and managing the agricultural waste. We talked about biochar, its utilization as a biochar, and now we come to the kingdom. It has a dry land, sandy soil, right? sandy soil, we know that cannot retain much moisture. Alkaline, of course, the pH is above 7. Low organic matter, because rain is not there. There's no like weathering effects. There is no like a vegetation on the soil. So that's why, you know, the organic matter is poor. So all this makes poor water retention. So we need something to improve water holding capacity of the soil. And we know this that KSA is among one of the water scarce countries. So here water is like precious. And whatever the water is available, 87% is going to utilize in agriculture industry. So we have, if we are going to amend soil, we are going to reduce water consumption. Then come to the climate, which is like temperatures increasing, why increasing, carbon dioxide and all these greenhouse gases are going into the air, increasing overall temperature. So we have, if we are going to concentrate on CO2, methane and all these gases, we can lower or reduce this effect. So what is happening? We are going to have a longer droughts, extreme weather conditions. So this also, you know, giving us a motivation to have a low carbon pathways to mitigate our this climate damage. So all these things, the biomass is available. The technology is there. We can make, in this case, biochar, biomass, biochar. We have a scenario in front of us, and that is the kingdom where the soil is sandy loam, water is scarce, and globally we know that, you know, the climatic change is going to happen. So we have a good rationale for our study to have all these components in front of us to use biochar on applied side. So we put these three major objectives in front of us, that we have to, first off, we got muffle furnace, we can build biochar, lot of studies shows that. But what we have done, we built up a prototype furnace. I'm going to show you the furnace picture, and thanks to one of our program, Dr. Majid, head of the program, so he made the furnace. So that was one of the objectives, that we have to have a prototype furnace. And then we have to determine the quality of the material, the biochar material. What is the quality of that material? Is it usable or not? What are the pros and cons of that material we have? And then we have to use it like on applied science thing. You know, is it a usable material, whatever we have? Because since yesterday we talked about there are some like pros and cons with this material. So we try to use it to study its morphological parameters, physiological parameters, and biochemical parameters using this cucumber crop. So our study, you know, comprised of these two components. We built up a prototype furnace, and then we applied the biochar derived from that furnace. So here we are, the furnace. This is a schematic diagram. Again, thanks to Dr. Majid, head of Date Palm Engineering Precision Technologies program, and we have mentioned this one in one of our papers, where we use leaf biochar, stem biochar, and the soil, which was sandy loam. Just couple of pictures. That furnace we use. Feedstock we use leaf and stem. Here, thanks to Dr. Ghazavi, he really helped us to have this material. So how we produce biochar? So this is a small scenario that we got this residues from, we left it in the field for this hour, we chopped it and we further dried it at 60-degree temperature, and then we placed it in the prototype furnace. We had different temperature experiment, and then we came to a point that this 300-degree temperature for 2 hours is where the pH is not very high, and we can play with the pH and EC as well. So that's why we choose 300 temperature. So we received this black carbonized material, and then we left it room temperature 24 hours, and after that we meshed it and stored it in a sealed container. You can see here the scan electron. This is our material we use. In the bottom is SEM pictures, couple of. You can see a lot of pore spaces, quite good pore spaces where they retain nutrient, macronutrient, and microbial activities is there, moisture is there. So this is very ideal to use it. Another couple of things, the fronds, leaf fronds, you can see the pictures, and then the powder form. Here we can, it's worth mentioning that we have ordinary biochar and activated biochar. We activated our biochar. Since like yesterday, people talk about the used biochar, but I think they didn't talk about the activated biochar. The beauty of activated biochar is it lowers the pH, it neutralizes the pH. So like I said before, you can treat it with any acidic material, whether it is soil, like I put an example of British soil, they are acidic. So we use that one there, and results were very good on zucchini plant. And we treated it with celery. I'll mention it here. I use the pig celery. So here I want to use camel celery. So then we want to see, and we treated the date palm biochar with the pig celery for 3 months. We activated it, right? So it lowered because the material was acidic. So this has high pH, alkaline pH. So we mix these two things up and leave it for a time, and then we use it for flower production. Like I said, Antrinum, we got a data for that. Fantastic, we can use it. And we had a analysis of that material as well. And we had an analysis from Yara. Yara is a very good company in Britannia. You just send them the material, and they will screen out all the profile. So, okay. Anyway, this is how we treated here. It's this already published material. Phosphoric acid we use, and that is a procedure available in the literature. So that is what we use in their King Faisal University this year. Design we as a 2 factorial design. Why 2 factorial design? We had 3 like a feedstock. We can say 1 soil, 2 feedstock, leaf biochar, and different field capacity, moisture content, 100%, 80%, and 60%. So this was the little bit crop husbandry. So we got the variety from Britannia, And then we, in a growth chamber, we got plants, true leaves, we move them, transfer them, and then we use 5% volume by volume. Yesterday, that was another question. Volume by volume. Someone mentioned that weight by weight. I tried that one, but no result, to be honest. It increased the pH, and then, we use volume by volume, 5%. Okay, this is a little bit the analysis of the data, the solar radiation within glass house, temperature, relative humidity. So these are the parameters, the morpho-physico parameters. So these are just a couple of pictures we have done. The results, what results we have got? How much time, Doug? Time? Yeah, okay. So I'm sorry. Yeah, I'm sorry to say that I have 3 things here just to save time. We have graphs, we have a heat map, and we have a correlation thing. So we can see here that, if you see the blue line is control, and then the orange is leaf biochar, and the gray one is stem biochar. So you can see that all these parameters, what we have, what we have is, thank you very much. We have like a vine length, stem diameter, plant spread, or days to flower, days to fruit set, maturity. So you can see all these, the red mean the time or the data is higher, and the green is lower. I mean, there is a legend on the heat map as well. So you can see the correlations, you can see some has like around 1% or 98, 91, 99%. So quite good correlation between the variables. We can see here that, the stem biochar mostly at 10% field capacity higher, but quite few, we can see a promising results when the temperature, when the field capacity is 80 or 60. If we compare 80 and 60 in the control, is much lower figures or like negative figures, and still wherever the field capacity, the moisture content is 80% or 60%, using leaf biochar or stem biochar is much better results are there. So I mean, it is, you can see it. So the next one is like leaf numbers, leaf area, we focused on the leaf. The leaf area index, and specific leaf area, and leaf dry matter content, and leaf thickness. Leaf thickness actually was our main variable. That's why we consider, because to calculate leaf thickness, we have to calculate the specific leaf area and the leaf dry matter content as well to get that the models for leaf thickness. So leaf thickness is showing wherever the leaf biochar is followed by the stem biochar. You can see on the heat map the red, so the value is higher than the other, and you can see easily the correlation is leaf thickness, leaf numbers, all these leaf area, there is a very good correlation of these parameters. The next one is our gas exchange system. So we have a recorded chlorophyll content, photosynthesis, stomatal conductance, intercellular CO2 concentration, and transpiration rate, and water use efficiency. So we all see, we see here, there are 2 clusters here which are like water use efficiency and CI. They are like, have one group of correlation. The rest is with the gas exchange, the photosynthesis, and the evapotranspiration. So all these characteristics, if we see, they're much, much better. All, like wherever we use stem or leaf biochar, 100% field capacity, and still the result is much better than control, which has got 100%, the control, which has got 100% field capacity. So using the leaf biochar, stem biochar at 80%, 60%, they are also giving very promising results. The next one is the number of fruits per vine, the fruit length, diameter, volume, and fresh weight, and the yield per plant. So they are like, if you see the correlation with the factors, I mean, obviously these factors correlate because these are the yield components. So they correlate, which is positively correlate. So we can see their relationship here. And then again, they are far from better, with comparing to the control. The heat map, you saw, leaf 100%, all red, higher rate, and stem biochar 100%. Also, this is morphological. We have dry matter partitioning. So if you see the fresh weight, dry weight, stem, leaf fresh weight, dry weight, and the root fresh weight, dry weight. So you all see much, much better, their correlation with the variables and their interactional performance is much better through the graphs. The next one is the color one. We also try to, because very limited literature is available, the effect of stress, water stress on the color of fruit is on edible fruit, but not cucumber vegetable, which is not botanically, but we use it as economically a vegetable. So we recorded its color as well. So its lightness is green to red color, and then blue to yellow color, chroma, hue angle, and delta C. We recorded all these things. They are much better as compared to the stressed plant in control. Last few, no. Yeah, that is, yeah. Last one, yeah. This is the fruit firmness, right? Which correspond to whatever it should be at high level of moisture available and at low level. So we can see here as well, where there is more moisture content, the fruit are like a soft, the firmness is reduced, and all the pH of the fruit, the total soluble solids, the total sugar content increase where the more water is available. And the proline content is also a very good indicator. When there is a stress, the proline content increase to show that to give a to trigger the plant that you are under stress, right? And the fruit surface area we have, and the relative water content, which is also essential to know that how much water content retained at different stress levels. Yeah, this is the last big picture of the correlation. So we can see here, like we divided it, very obvious that we divided it into two hierarchical clustering. So we can see one is with the color and different water use efficiency, and these parameters, they are in one cluster, and the rest of main of the cluster on the far end side, all these parameters, variables, they are in a second cluster. It's a big chunk of clusters, they correlate to each other. This is the chord diagram. To be honest, our subscription was finished, so we will complete it in in our paper. So the conclusion, just last one, we made we have done the prototype furnace. We have done, we got the leaf stem biochar, and we evaluated its properties. Nice one. So we concluded that although 100% field capacity we maintained in sand and leaf biochar, stem biochar, they were superior. But still, if we maintain that capacity, field capacity within using these material, we have far better results than in the control factors or whatever it was. So we improve yield and things like that. And so the last one is that we can, still there is a window to use 80% or 60% field capacity, where we can save 20% or 40% water. And in this, where the water scarce in the climate where water is scarce, we can still, it's a 20% or 40% lot of water. We can save it at a very little expense of morphophysiological and biochemical properties. So we can compromise at one point to save this matter, so it's not going to make a big difference. Yeah, thank you very much, sir. Yeah, you take this one. Okay. Sorry, I think, yeah.
Thank you very much, Professor Mohammed Munir, for your presentation. Now I think we are running out of time, but we still can maybe take two questions, short questions. Please, any question?
Thank you, Dr. Munir, for your presentation. My question, I ask about the relationship between temperature and time for preparing biochar. You said 300 temperature is good. If we increase that effect in the biochar properties?
I mean, yeah, I think you were the part of that thing. Yeah, we increase it, and we've seen that, it affect the nutrient content of the plants, the pH increase. So that's why we maintained it. It was, it was 7.8 or whatever in the properties. So we tried to, we had that pH when we treated it at 300 at that specific time, 2 hours. We played with this. We increased the time, the temperature, and then we saw that, is not, it is increasing the pH and reducing the nutrient content. So we just stick with at that temperature and that time interval, the 2 hour. So and then we activated it. We found a way to activate it to further reduce the pH. You were there with me. So we played with the black material all day, washing it up and blah blah blah. So and then counting the pH, so reduce it. But I think, if you don't want to dirty your hands, use organic material and play with this rich in phosphoric, the urine thing, the camel urine, animal urine, celery even, liquid celery, not the solid one, because liquid one take less time to activate your biochar. So if you play with that material, you can reduce pH. You can, if you have a nutrient content evaluation, you can see if it is good, 2 months, 3 months, whatever, depends on the material, whatever the biomass material you have. You prepare the biomass biochar from that one. So it's a kind of, yeah.
Second question, you see this production of biochar is economically here, مثلا as in Saudi Arabia, because the pH play a big role to add it in the soil?
The thing is, again, Doctor, is I think you are going to with Dr. Majid, and you will include me as well, to reduce the cost. You know, when the feasibility of application of this material is a major question mark. So if we use like solar energy, so Dr. Majid is, you know, so solar energy to convert this material, it may take more time, but we can reduce the cost. At this movement is okay, it's a science we are playing with, right? So maybe this could be a pioneer research, and then someone like playing with the solar radiation and things like that, reduce the cost and make it more applicable.
Okay, another last question maybe.
Thank you so much, Professor Munir, for such a nice presentation. I'm Dr. Mukarram from Imam Abdul Rahman bin Faisal University. Related to the, I'm concerned that, did you find the textural properties of the biochar you have produced?
No, I'm sorry, no.
So because you have shown the scanning electron microscopy,
yeah.
so I'm concerned about the pore size.
Yeah. We were interested to find a difference between activated biochar, because when you activate it, you have a more pore spaces. Exactly. The size is increased, surface area is increased. And we also had that one of the objective, that when it is in the literature that it increase the surface area. So, but that one was ordinary. We requested, I'm not going to say anything else, that we requested to use that material, but we failed. But we'll try our best to have a proof that it really increased the surface area.
Okay.
Yeah, but I'm sorry, we didn't do that.
Okay, thank you.
Yes. Yeah. Thank you, Dr. Munir. Actually, regarding the pH reduction and using the urine by nature, it is alkaline and it has ammonia almost.
Yeah,
and are you going to sterilize the urine or you use it as fresh? And you say that activation period is 3 months. Yeah. Even with the 3 months, urine pH will be higher. Then I pretend this will not be the proper solution. I would advise, as a soil scientist, to reduce the pH, you have to add gypsum. Gypsum will add calcium, and the sulfur will reduce your pH in the soil as well as in the biochar. Thank you.
I just mentioned here just one thing. I used not gypsum, but I used sulfur in a laboratory experiment. I used sulfur, and that is also taking long time, doctor, to get like that desirable pH. But that thing, like you said, that idea came from one of the grower there in Britannia. I used to work with a satellite GIS company there called Soil, SOIL. So they scan, using GPS technology all in UK. So I talked to the guys, what is the possibility? And they said that we are using this pig urine for 6 months, for 3 months to get it neutralized. So I got that idea from there. So I used that one, right? And another maybe, because there is always rain. That may be, if because you are just mixing that material and leaving, in the field and just covering it with some sort of cloth or something. And then after like 2 to 3 months, I took the samples. I sent it to the Jara company, it's a big company. So I asked them to analyze it because that was the environmental material. So they like has in the properties, all the heavy metals, they scanned the nutrients and all the pH, all these things, and it was like ideal, 7.8 or something it comes, or 7.4. We have to compromise with the phosphorus or a couple of more nutrients while using this biochar, because at little bit high pH, they are like not very available things. So, but like you said, yeah, we can, use gypsum or sulfur. I am playing with sulfur, sir. Yeah, because acid definitely reduce the pH and yeah, obviously. Thank you, sir.
Thank you very much, Professor Munir. I think we came to the end of this first presentation. Thank you very much. So now I would like to call for second presenter, Mr. Saeed Al-Hotari from King Saud University. Please come. I would like to remind you about the presentation. It will be maximum 12 minutes, and it will be 3 to 5 minutes question and answer. Please stick with the time.
السلام عليكم. As you can see in the screen, my presentation is about microwave-assisted production of hydrochar by hydrothermal carbonization of date palm biomass and its application removing dyes from wastewater. I have divided my presentation into 7 parts: background, hydrothermal carbonization process, problem statement, objectives, material and methods, results and discussion, and conclusion. The vast majority of agriculture biomass waste is not industrially recycled. It's frequently burned and releasing pollutant in the atmosphere, and this causes several harmless in the environmental. Agriculture biomass has become known as dependable source of carbon materials due to its readily available. Several studies turned the biomass into a useful material as low-cost carbon material, such as activated carbon, hydrochar, and biochar. Hydrothermal carbonization process is a process that takes place under a high pressure and at low temperature, greater than 160 and less than 250 in a water medium. Due to relatively low emission and the generation of harmless waste, the hydrothermal carbonization considered to be environmentally friendly. The reaction time can be short, from 1 to 2 hours, as for monosaccharides, and long, up to 48 hours for cellular biomass. Hydrochars may contain carbon microsphere, and this is a useful product for industrial application due to its inverted surface functional groups. As we can see in the screen, there's a formation of carbon microsphere from glucose, sucrose, and from date molasses. Date molasses contain 40% glucose, and the picture here, image A and B, at 2 different times. So the date molasses can produce, or biomass can produce the carbon microsphere at low low temperature and short time. Obtaining carbon microsphere from the monosaccharides such as glucose and sucrose with hydrothermal carbonization method is relatively easy. However, it's more complex with the cellulosic material due to its compact structure and the high crystallinity. Several studies study to convert the biomass into a useful material, such as here in carbon microsphere and hydrochar. Zubair et al., they use argan nutshell biomass to produce a carbon microsphere. in 180 degrees Celsius and for 6 hours. And also same for Costa and Zhang and Sevilla. Our problem statement or the need for this research is that date palm waste or date palm trees generate a huge amount of waste, and an average tree produced from 20 to 40 kilograms of waste annually. The date palm waste is currently rarely used in industrial application. It's often disposed of by burning, as I said, and this is it's harm the environmental. Date palm biomass contain a high proportion of cellulose, which has a high convertibility into carbon materials such as activated carbon and hydrochar and biochar. Preparation of hydrochar using hydrothermal carbonization process for cellulose can be taken about more than, it can take several hours. And there's need to use low cost and low time to prepare a carbon microsphere. So any applications, the microwave heating shown good results, and due to its uniform heating and rapid heating also. As we can see, our objectives of this study is to synthesize hydrochar from date palm seeds using microwave heating. Also to investigate the effect of process parameters such as power, reaction temperature, and duration time on mass yield, and to evaluate the adsorption capacity for removal of methylene blue from wastewater. Why hydrochar? Comparing hydrochar and biochar to a commercial activated carbon, there are several benefits: low cost material, high content of oxygen containing functional groups, low content of concentration and impurities, and easily modifiable structure. Raw material processing. First of all, the seeds the seeds were obtained locally from a local date factory in Riyadh, and the biomass was first cleaned with deionized water and then placed in oven, and after that it's grinded and saved until we have less than 0.25 millimeter particle size. As we can see here, the biomass, waste biomass, mixed 1.5 of seeds biomass mixed with 15 milliliter of deionized water and ignited for 1 hour. And after that, it has been powered into 100 milliliter Teflon and then placed in a tank eco microwave digestion extraction system CNU from China, as we can see. After that, the mixture placed for the different parameters such as energy power and reaction temperature and reaction time were investigated. Each experimental was conducted using 3 temperature stages to ensure there is no sudden increase in pressure. After completion, the system left to cool down until 60 degrees Celsius and then removed from the microwave, and we get the dark thick liquid. This dark thick liquid were cleaned and washed with the ionized water and ethanol, and after that it placed in oven for 24 hours at 80 degrees Celsius, and after 24 hours we get a hydrochar. The hydrochar, the mass yield, here's the equation to calculate the mass yield. And WO is the dry weight of the raw biomass. WC is the weight of the hydrochar. After that, the produced hydrochar has a relatively low surface area and low bore volume, so we need to activate it to increase the surface area and to have a high absorption capacity for methylene blue removal. So we get through activation of hydrochar using incipient wetness impregnation by phosphoric acid. We have 85% phosphoric acid, 3.5 milliliter with 1 gram of prepared hydrochar. The impregnation was taking place in for the drop-wise with continuous stirring, hand stirring. The impregnation sample was dried for 12 hours at 110 degrees Celsius. After that, the impregnated sample was subsequently carbonized for 90 minutes and at 550 degrees Celsius in a horizontal tube furnace. The characterization SAM to see the surface morphology and BET to measure the bore size and bore diameter and surface area, and of course FTIR to identify the presence of specific functional groups. Here is we investigate about 25 samples with different temperature stages, different time, and different power, energy power. And the best sample gave us number 13. It gave us at energy power 450, the temperature between 140 to 180 degrees Celsius, and the time was 25 minutes. And the yield, we got 68.93%, and the BET surface area was 85.64 meter square per gram. Here is SEM. As we can see, there's a carbon microsphere. And the first two, or the two pictures at left, this is the hydrochar, and the one at right, it's the activated hydrochar. As we can see, there is a formation of carbon microsphere, and the activation process did not change the morphology, especially phosphoric and acidic activation did not change the morphology of the hydrochar. Surface area, for sure, it increased through the activation. It increased from 85.6 to 1,089, and the bore volume increased from 0.35 to 1.72. Bore size, it has been between 14.6 and 60.9, which classified it as mesoporous according to IUPAC. This is FTIR, and as we can see, the functional groups present in the samples, the hydrochar and activated hydrochar, and after methylene blue adsorption. We studied the effect of dose, so we changed the dose 0.1, 0.2, 0.4, 0.6, and 1 gram per liter, and we found that the optimum dose that gives us high adsorption capacity for methylene blue was 0.4 gram per liter. And we studied the pH effect and found that at pH 6, the maximum adsorption capacity was achieved. The initial concentration or effect of initial concentration was studied, and we found that at the equilibrium, or the initial concentration has the equilibrium was at 300 milligram per liter, and about 285, it's around 285 So the 300 milligram per liter was the optimum concentration. After that, we study adsorption isotherm as Langmuir, and we found that the adsorption follow the Langmuir concept and with R square 0.999, and the maximum adsorption capacity was 285.07 milligram per gram for methylene blue removal. Conclusion. The microwave heating system successfully synthesized through hydrothermal carbonization using microwave. The maximum yield is 68.93, and the temperature ranging from 140 to 180 degrees Celsius with a power of 450 watt. The temperature and powers above 200 degrees Celsius and above 600 watt do not affect the yield improvement. The BET increased from 85.46 meters square per gram to 1,089 meters square per gram. The bore size of the synthesized material range from 14.6 to 6.9 nanometers, classifying them as a mesoporous material, which is have high adsorption capacity that can be suitable for wastewater treatment. Future work. Comparing the results with our recent finding in carbon microsphere prepared by a traditional method that we use autoclave in a furnace, and the long time, as we can see at 25 minutes we get a hydrochar, but the conventional method at 3 hours for molasses and 4 hours for seeds. So we can make a comparison between the two methods, and the activating the prepared hydrochar or activated hydrochar by dibutectic solvents or ionic liquids, it may be has improvement in the surface area or in functional groups that can absorb methylene blue efficiently. This is publication related to this study, and this is the references. Thank you for your listening, and
thank you very much, Mr. Saeed, for your presentation. Now we open the floor for questions and answer, maybe 3 or 4 questions at maximum.
Assalamu alaikum. Thank you so much. Regarding the yield, you have mentioned 68% in the hydrothermal treatment. But what about the yield after activation? You didn't mention about this. And second question is related to the surface area. Because the surface area, I have found that it increased significantly from 85 meters square per gram to more than 1,000. So it seems to be, did you validate the results, or because I didn't find any study then in this, the surface area significantly increased to greater than 1,000. Maybe it reached to 500 or 600.
Okay. In our conventional method for seeds, we rise temperature, we rise surface area from, it was about less than 10 meters square per gram, and we rise it to 1,600 using a conventional method. But here using microwave, we got 100, and as you can see, can you as you can see this table, we have this for the hydrochar, not activated hydrochar. Related to the conventional method, we have a surface area 85.64, while in the other method it's less than 10. So it indicates that the rise in temperature is, it's you know, you can imagine the rise in surface area.
Any more questions?
Yes, one.
Thank you very much for your very nice presentation. I have two questions. One is based on the scientific results, and the other one is just a comment. So, based on your data that you got, maybe did you consider cost analysis, especially in terms of if you compare hydrochar and biochar, did you check on this part? And I have comments regarding FTR results. I don't think because you have too much vibrations in your data, maybe other software could help in smoothing up the spectra. And another comment also, maybe could be part of your perspective is to check on the metal ions, maybe absorption on the surface, and could help for other applications regarding use of hydrochar, maybe for soil amendments or something like that. It's something that we are doing right now, and maybe we could collaborate together. Thank you very much.
Thank you for your comments. And for the economic study, as we can see, our method or conventional method, it's take about 4 hours of heating, and this consumes a lot of energy. Now in this method, we just 25 minutes, the less energy, and we are aim to have, if we got a way to reduce it to 5 minutes, it will be okay. But we are looking for the formation of carbon microsphere to ensure that the functional groups will be okay, and we can activate it and make the porous on the carbon microsphere to capture or to absorb the methylene blue or heavy metals. Thank you.
You have done the microwave process in water medium. Is it true?
Yes.
To get these microsphere particles.
Yeah.
Have you tried another solvent, organic solvent, to reduce the size? Because for advanced application, the size matter. For example, advanced application like solar cell, where we to grow thin films, this microsphere, is big in size. Therefore, I don't think so they are suitable for that. But if they reduce in their size into the nanoscale, maybe by changing some another solvent or something, have you tried?
No, not yet. Maybe in future work.
Okay, thank you very much, Mr. Saeed. Thank you very much. And now I call for the next presenter, Dr. Abdul Rasul Al-Umran from Saudi Arabia. تفضل دكتور.
Assalamu alaikum wa rahmatullah. Thank you, Mr. Chairman, and thanks the organizing committee for giving me this opportunity to present our work. Actually, Dr. Munir took most of the time to, and he took, same work that we are working. He talked about the water conservation and producing the biochar, and the only thing that he missed is the salinity. I think you. But anyway, my presentation, the title is the use of biochar to improve the hydrophysical properties. It is a completely different aspect. That what we need to work on it in Saudi Arabia, how to conserve irrigation water. And one of the methods that I've been working on it on improving soil physical properties to keep the water in the root zone if it's possible. So that's the goal of my talk, and the goal of using biochar as a soil amendments with other soil amendments, compost or polymers or clay deposits. I've been working on this for the last 30 years as water conservatives. How can we really conserve water with that? Is it possible? This is the questions that we're gonna. Which one, the red or green? Okay. It's not moving. Appreciate that. Shukran. الأحمر. سو الأحمر. إيه خلاص. من البداية؟ إيه لا من البداية. دعم. Okay, thank you very much. I don't wanna repeat what Dr. Munir and yesterday Dr. also mentioned about the Saudi Arabia in arid region, and most of the water being used in agriculture, almost 90%. And most of the agricultural soils in Saudi Arabia is sandy soils, calcareous sandy soils, and these have some concentrations or negative signs, such as low water holding capacity, excessive deep percolation, high infiltration, low water use efficiency, and so. So my main focus on this is, can we improve irrigation water management in these soils? A previous finding or early research we done on that using the polymers, chemical polymers, and organic matter and the clay deposits. Honestly, I found the clay deposit is most useful one and the cheapest method to use to improve the soil physical properties. And lately, as adding soil amendment can increase water use efficiency and decrease water loss during the irrigation. Can we use the biochar? Actually, biochar has been introduced to the department by my student, and now my colleague in soil science department at King Saud University. He's a soil chemist, so they are working on carbon sequestration of the carbon in the soils, and we asked him, can we use it also to work on physical properties? And this is what initiated, that was 8 years ago, and since we are working on different methods of using biochars in order to improve soil physical properties. The use of biochar has been examined by us on improving hydraulic properties of the soil. Depend on so many factors. I'm going to list these factors actually in the biochar: temperature, amount, rate, so many particle size, how much you added, is it nanoparticles, small particles, macroparticles, which will affect all the result of saving water. The soil amendments include the organic and inorganic, improve the soil properties, resulting in better condition, enhance soil aeration, soil infiltration, enhance water holding capacity, and so I'm going to go fast because already Dr. Munir talked about that. The palm trees in the kingdom, this is a photo from my region. I'm from Al-Ahsa, so that's, although I'm working here, but this is what they do actually in Al-Hasa. That was in the past time. They collect all the residue of the date palm, and then they burn it in the field, and this we call it and I tried even my relative to switch to biochar rather than, we call it a tabina in our region. That's but still it's very hard to convince the farmers because they use it. They say this is will get out of the insects and many things that we use it as a nutrient. So when we do the tabina, so this is actually what is. And we started our research in a small in the lab, in a small furnace, as you can see. And this is biochar production in the field. This is what we have in the field, as you can see from the last photo on down, huge containers to produce the biochar. And then we crush it and bring it to grind it to less than or 2 millimeter and less for the application of the biochar in the field. This is some of the characterization of biochar that we have. I don't want to stop here because this is already repeated yesterday and today in the morning. But you can see at different temperature you will have different also characterization of the biochar. Here, for example, the EC and the pH, as you can see, it's very high. It's 8 and 9 and 11, while the EC is acceptable. Some literature will say that the EC is over 10, but this is what we found in our research. What we are looking for in soil physical properties related to soil water, what we should measure, what are the parameters that we should do in order to say, well, this will give a good sign or negative sign for using the biochar. Mainly the water holding capacity. Can these materials, after mixing it with the soil, will hold the water, and water infiltration will reduce or decrease the infiltration rate of the sandy soils, and saturated hydraulic conductivity will be less, water retention and plant available water and bulk density, aggregate stability, all these parameters should be done as a soil physical properties. It should be also to compare whether the biochar that we are using or the effect of biochar is useful, or can you use the biochar or not. The factor influencing the biochar itself is pyrolysis temperature, and many people talked about the temperature. Is it better 200, 300, 500, 600, and so, and the rate or the amount that we add the biochar to the field or to the columns that we are using. Placement also, where do you put it? Where do you put the biochar that you have? Do you put it on the surface or underneath? And how deep? And this is all when so many experiments that we gone through to reach to a better conclusions. One of the main factors is the particle size of the biochar, which size that you
CO2 emissions in last 2 decades. It is expected that it is going to be increased by a factor of 0.9% by next year. And the major contributing sectors for the CO2 emissions, apart from the electric power and industry, we have industrial sectors like chemical industries. Transportation sector contributes to about 29%, and we have agriculture as well, which is contributing to around 10%. So currently the researchers and scientists are mainly focusing on a sustainable and viable approach to cut these emissions in a sustainable manner. So apart from this, according to the published work from Arab News in 2020, around 53 million tons of bio-waste is generated in Saudi Arabia, which is generally or mainly dumped to the landfill. So this is causing significant amount of greenhouse gas emissions related to CO2 and methane, which is also causing devastating impact to the environment. And you can see it here from the other figure that these bio-waste can be used as a cost-effective and sustainable source material to produce value-added products such as adsorbents, soil conditioners. It can be used for to produce magnetic materials, alloys. So there's a huge, you can say, potential to use these bio-waste into a value-added product. So related to biochar, a lot of discussions has been done in previous lectures that biochar is a carbon-rich material which is generally produced from the pyrolysis of biomass. This could be agriculture waste or animal waste or any bio-waste generated from the industries. And it can be produced at a temperature from 300 to 1000 degree. And because of why the biochar is getting more attention, because this is a viable route to transform the waste material into value-added product, the abundant availability of the product, low cost, and comparatively the structure of biochar is mainly porous in structure, functionality, right, depending on the process conditions, and the surface area is comparatively from 300 to 700 degree, so it can be used for a wide range of applications. Plus, the main advantage of using is the chemical and thermal stability. So it is getting a lot of attention, particularly for soil amendments, as discussed in the previous demonstrators. Water purifications already discussed, and even it is also getting more attention to capture CO2 from different source, point of source, such as direct air capture as well as from different industries. So you can see it here, the carbon dioxide removal from the biochar. So according to the life cycle assessment of the biochar, so it is estimated that if you are producing 1 ton of biochar from the biomass, so you are going to capture 2.63 to 3 tons of CO2. So this is from the life cycle assessment, normally generally published in different previous studies. And according to the US International Biochar Initiatives, they state that you can cut around 6% of the global emissions, CO2 emissions, which is equivalent to around 3 billion tons if we are producing biochar from different biomass. So that's why it is called a carbon negative material, and it is getting a lot of attention. It can be termed as a black gold, carbon black gold. Secondly, you can see it here, as I told you in the previous slide, that biochar is a highly porous, exhibit a highly porous structure. So it can also be used as a sustainable adsorbent material to capture CO2 from different industries which are generating VOCs and as well as CO2 because of highly porous structure. So it is also a basic in nature. So CO2 is acidic in nature, so there are some electrostatic and Lewis-based acid-base interactions. So it can be termed as a sustainable, low-cost adsorbent material to capture CO2 from the different industries, as well as in direct air capture. So you can see it here from the previous studies, around the biochar has absorption capacity of around 70 to 120 milligram of CO2 can be absorbed by using 1 gram of biochar. So regarding the potential, as discussed in previous lectures as well, Saudi Arabia is the third largest producer of date palm trees, and around 25 million trees are present in Saudi Arabia, which is generating around more than 200,000 date palm waste. So this is a promising potential feedstock material, can be transformed into biochar, and this biochar can be used for a wide range of applications as soil conditioner, wastewater treatment, as well as for CO2 capture. And it is as well as it is also mentioned in previous studies that it is almost, compared to the other solid adsorbent which are used for the CO2 capture in different industries, it is almost 10 times cheaper than other the commercial adsorbents such as zeolites available in the market. So based on these studies, we evaluated the performance of our date palm fronds. We collected these date palm fronds from Al-Hassa city, right? You can see it here from the left side picture. And then we sieve it, and then we produce a biochar using a simple process, slow process at two different temperatures. So the temperatures we have selected in this case is 700 degree and 800 degree. Why we have selected this temperature? Because we are looking for highly porous and high surface area biochar. So according to the previous studies, 700 and 800 degree can give us a high surface area and highly porous structure, which is highly feasible for CO2 capture. However, for soil conditioning, as Professor Munir already mentioned, 300 to 400 is good for the soil conditioning application. So depending on the type of application, you can produce your customized biochar. So we can see from the structure, the one from 700 degree, you can see the structure of the biochar. The pores are formed, but these pores are comparatively bigger. But when we increase the temperature to 800 degree, the pores, well-developed structure, pore structure has been formed, and because of the increase in surface area, removal of volatile organic compounds, which is favorable for the adsorption of CO2 from the gas stream. So in order to evaluate the adsorption performance, we use our lab-based fabricated adsorption column. So you can see it here on the left picture. So this is the adsorption column we have used, and we have used different embedded with different sensors, inlet CO2 sensor, outlet CO2 sensor, and we perform range of experiment by evaluating the effect of different parameters like gas flow, temperature of the adsorbent column, and plus the size of the biochar, the particle size of biochar, because these are the main governing parameters which can affect the performance of the CO2 adsorption. So in this slide, I have shown just some few results related to the adsorption capacity. So you can see it here. We have tested 4 types of biochars which are produced at 2 different temperatures and 2 different times. So you can see it here. 400 at 800 degree produced at 2 hours, and 700 degree produced as 4 hours showed better adsorption performance compared to the 800 degree produced at 4 hours. So you can see it here, even the increasing the time of the production is not feasible because there is some sintering effect as well. Because when there is a pore formation, so if you increase the time of the paralysis, so these pores starts to break again and blocking the other pores. So that effect is called sintering effect. So based on the adsorption results, we found that 800, the biochar produced at 800 for 2 hours is generally feasible for the adsorption of CO2. So these are the parameters we have fixed. Biochar amount 5 gram, void fraction 0.3 to 4, depending on the EPA guidelines. Gas flow 100 ml per minute, and CO2 concentration we have used the fixed concentration 2,800 milligram per liter. So based on the results, we did some design calculations, and we come to know that using the biochar produced at 800 degrees for 2 hours, so we can capture around 5.1 gram of CO2 per gram of biochar. So this shows that the biochar produced from date palm fronds can have high potential and can be used as a sustainable material for the capture of CO2 from different point sources, like from air as well and from different industries, compared to the commercial adsorbent. So regarding the SWOT analysis, this is a journal. So in terms of strength, you can see it here. It is a carbon negative technology. If we are producing biochar, we are sequestering around 2.633 tons of biochar per ton of biochar, right? Plus, it can, because the source is sustainable, so it is a sustainable adsorbent material, cost effective and low environmental impact compared to the other available adsorbents like currently the researchers are focusing on 2D nanomaterials. However, these 2D nanomaterials have high adsorption capacity, but they are, if you go to the scale up or environmental impacts, if you go to the life cycle assessment, so they are not feasible for commercial application because of their complex production phenomena, right? So plus, the main advantage, another advantage is highly stable because commercial adsorbent like zeolite, they are not stable at high temperature, particularly for CO2 adsorption. So if you are going for the regeneration and reusability point of view, so these zeolites material are not feasible. But biochar is highly stable and it showed promising reusability stability. Apart from the strength, so if you go to the weakness, compared to the other materials, the adsorption capacity is comparatively low. So in that case, we have to go towards the activation of the biochar or producing some engineered biochar. So the work is focusing on development of engineered biochar so they can perform similar to the commercial available adsorbents. Plus, as discussed in the previous discussions, that we have a low market awareness. So there's less awareness in terms of educational institutions, in terms of applications like farmers and other industrialists. So they are, so this is the main weakness of using. Plus, there are some standard protocols provided by the International Biochar Initiative and European biochar industry. So there is less adaptation of these standard protocols because based on these protocols, you can say that this biochar can be used as a safe material and can be used for CO2 capture and other applications. We have some other applications of biochar. It can be used for composite industries, plus it can be used as a carbon neutral negative concrete material. Plus, there are some threats limited because there are not a lot of advances, particularly based on the technology, right? Because if you are considering the conventional pyrolysis process, though this can be termed as energy extensive process, but new technological advancements, they are more energy intensive process, so which can lower the emissions of biochar production as well. So there another threat as well, not all biochars are good for the adsorption. Not all biochars can be used as a soil conditioner. So there's a threat as well. So these are the main things which can limit the application of biochar, but still the research is going on and there's a possibility that after few years this biochar can be a game changer and it can be used as sustainable adsorbent material to mitigate the CO2 emissions and can have significant effect on the global warming mitigation. Thank you so much. So if you have any questions.
Thank you very much, Dr. Mukarram, for your presentation. We take one question. Yes, please.
Thank you for good presentation. I wanted to ask about during preparation of biochar in the tubular furnace, how can you get rid from the fumes that produced during firing? Is it a closed system or opening?
No, related to the fumes, because as I told you, we use conventional pyrolysis system. So we just, we didn't control the fumes. However, if you are looking for the, if you go to the advanced technology, definitely in that case, you can use that fumes to produce biochar. The same energy you can use. In this way, you can reduce the energy consumption as well.
Thank you.
I think we need to stop here because we are late. Thank you very much, Dr. Mukarram. Thank you very much. So now I call for the last presentation, Professor Ham. Please come on the stage. Thank you very much.
Assalamu alaikum. Good afternoon, everybody. It is my pleasure to present some of the work that we have been doing at the University of Portsmouth, UK. I'm Hom Dakal. I'm Professor of Mechanical Engineering, and I also lead a research group called Advanced Polymers and Composites. So the title of our talk is Development of PCL Date Palm Fiber Biocomposite for Sustainable Packaging Applications. And we are looking at two different methods to produce the material. I put my stopwatch. Hope that works. It's a quick outline, so I'm not going to go too much. I'll try to be as quick as possible due to time constraint. So we are trying to look on dry blending and melt blending and comparing them in terms of performance for packaging applications. So we have some experimental work and some results and discussion. As we can see, packaging materials constitutes a huge amount of polymers, almost 46% of them. And then if you look at the diagram on the right-hand side, most of them are in linear, so they are not recycled. So there's a big challenge as well as opportunity to work in this field. So you can see the jet palm fiber-based biocomposite can be used in different packaging applications. So our focus has been more on towards the right-hand side, more packaging tray or packaging film materials. So we can see here two types of process that can be used or have been used currently, melt blending and dry blending. So here we are trying to compare these two techniques and see both techniques in terms of performance as well as environmental aspect or energy consumption. Well, you can see here the time and cost, energy, process, and the mixing is coming from melt blending. That's great, but the energy is a big concern. If you go to dry blending, obviously the blending itself is a challenge. Mixing materials is a big challenge. So our research question is, mechanical properties of melt and dry blending biocomposite, is there any difference or not? Where is the possible to improve fiber polymer mixing in a dry blending process? So this is two research questions that we have been trying to find the solution. Well, here we have used PCL as a matrix material, and then we have used jet palm fiber as a reinforcement material. So, well, I don't need to go to say why PCL. There are so many good attributes about PCL. Due to time constraint, I have to move very fast. I'm sure you'll all appreciate because we'll be waiting for lunch. So in experimental work, we have PCL. That was the material that we obtained with different melt flow and so on, and then jet palm fiber coming from Saudi Arabia, leaf sheath, and thanks goes to Dr. Fahad Al-Mansour for bringing this material to Portsmouth, or sending this material to Portsmouth. And then obviously we have approach one, polymer as pellet and fiber as grinded powder. So that's what we have been doing in this particular work, which I have reported here. And then another work is where we have grinded fiber as well as the polymer, PCL. So yeah, approach 2, that is what we are trying to do. So let me first share the result obtained from approach 1, and then I'll go to approach 2. You can see PCL pellet and jet palm fiber. PCL is made of powder and jet palm fiber. Then we use this cryogenic grinder to grind them. And then obviously dry blending. Then we use compressor molding using 120-degree 5 megapascal pressure, compaction pressure 10 minutes, and then normal air cooling, and biocomposite panel of that dimension, and different concentrations of jet palm fiber from 2.5 to 10 weight percentage. And then we look tensile properties as well as dynamic mechanical analysis, and then that's what I would like to present here. And then we also have done morphological analysis, the fracture surface of the specimens using SEM, and then obviously tensile testing. We also look weightability using contact angle measurement. And then we also have used DSC and TTA just to measure thermal stability. Right, in tensile test result, as you can see here, jet palm concentration has not improved tensile strength. Rather, it has decreased. But as far as the modulus is concerned, as you increase the volume, weight percent of concentration, it has improved. So you can see here a filler effect on modulus. However, the strength has not been increased. And then, so similar mechanical properties were reported in literature too. So slightly higher tensile strength in their literature, and then the modulus increased, but perhaps because of the grade of PCL used, we had slight different results obtained. So another work they have in the reference 3, I will show that reference in the end, thermal degradation and some other properties produced by extruser. So this is just quick comparison of literature, and here we use contact angle measurement to see the weightability. As you can see, increase in jet palm fiber has increased the weightability or decreased the contact angle. So obviously hydrophilicity of jet palm fiber would increase the weightability, which is good. So then we looked on DSC result, the heating and cooling cycle, as you can see with different percentage of jet palm fiber. The temperature has changed, and you can see here 100% PCL, melting temperature 58, and then with 2.5, 59, and 57. So it's slightly decreasing in terms of temperature, and crystallinity has also been decreased because of the inclusion of jet palm fiber. In terms of peak temperature and then onset of degradation, you can see the temperature has increased with the inclusion of jet palm fiber. And then crystallinity time has also increased. So that with that, you can see the shift in peak of this result. So the fiber has influenced crystallinity process, and crystallinity decrease with the increase of fiber contents. So on TGA, we have some results. Fiber started to degrade earlier than PCL. More the jet palm fiber contents created a more ash percentage. So this is the other finding that we have got here. From DMA results, the storage modulus and loss modulus has been increased with jet palm fiber inclusion. So this is the approach 2 that we are currently working, and that is both material being grinded, so PCL as well as jet palm fiber. So the conclusion is that dry blending fiber polymer and of jet palm fiber PCL composite manufacturing could be a potential alternative to melt blending process, which will enhance environmental performance. It will decrease energy consumption, which you can expect in melt blending process, if we can prove that dry blending is better. But we are still working on that. So it's a very comparable mechanical properties compared to available literature. So yes, and then also the on PCL, adding jet palm fiber has improved thermal mechanical performance, which is really good. And so we think that it can be used as a potentially sustainable packaging application, jet palm fiber blended in PCL. So so we need to obviously get some improved mechanical performance and optimize some manufacturing parameters for the dry blending. Approach 2.1 is continuing. And then, so we want to further work on the 3D printed material from this work. So these are some of the findings that we have obtained from this work. I want to see my time. Yes, 9 minutes, 43 seconds.
Very good.
Thank you very much, Professor Ram. Thank you.
We need a speaker like you, to finish on that.
Thank you very much. So we can take more questions, maybe. Okay, any question?
Yeah, thank you so much for such a quick presentation. Regarding the mechanical properties, so this is the main limitation.
Yeah.
So what do you think in future, that how do you improve?
Yeah, we can do some treatment on jet palm fiber and enhance the compatibility between fiber and matrix, and then enhance the performance. So that is one way we're thinking. Maybe the parameters can also influence the mechanical performance. So the compaction pressure that we have currently used and the temperature we have used and the dwell time we have used can be altered and see what is the effect of that on properties. Because this is ongoing work. This is a very preliminary result that we have obtained. And one of our PhD students who was appointed October 2nd, he's working in this field. So in the maybe next BIPALMA presentation, I'll bring a lot of good results, I hope.
Thank you.
Any more questions? No more questions? Okay, thank you very much, Professor. Thank you.
Thank you again so much for this opportunity and for your attention.
Thanks.
Hello. So we have the certificate for the presenter. So first of all, I call the Prof. Muhammad Munir. If anybody want to take photo. Saeed Al-Haw. Saeed, come. Abdul Rasul Al-Umran is not there. Mukarram Zubair. Absorption. We recently done on lignin, you know. Prof. Homdekal. Okay, last I call the session chair to come on the stage. So now the session is finished, so please enjoy the lunch and we are going to see you tomorrow, inshallah.